Okay, so for today's video, we're going to have to dramatically change the scale we're kind of used to. Because not only are we going to be leaving the galaxy, we're actually going to be going much farther away at distances in hundreds of millions of light years. And by itself, this is already extremely difficult to imagine. As a matter of fact, I'm going to have to fly faster just so that I can help you maybe sort of visualize what all of the scale here is going to look like. Okay, so in some sense, it's maybe this. But every spot you see, that's an individual galaxy. So yeah, try to visualize this and try to remember the scale. But I guess if you prefer two-dimensional images, here's a rough cross-section of this entire area. Here we're looking at what are known as superclusters. Multiple galactic clusters gravitationally attached to one another, creating much larger, much more massive structures that to some extent travel together across the entire universe. And one of the biggest discoveries in the last decade or so was actually a discovery of the supercluster you see in yellow. This is today known as Laniakea, an enormous structure made out of smaller superclusters, which are then made out of smaller groups, including of course the local group where the Milky Way is located. But when this announcement was made, a lot of media sources presented Laniakea as this. This obviously looked much cooler and more artistic, but in essence only showed us the motion of various galaxies, not the actual shape discovered. This though shows us the actual three-dimensional shape. And this was actually discovered back in 2014 using some of the new data that was released just a few months prior to this. Since then, practically 10 years passed, and there's now so much more data available that the scientists behind that discovery have now managed to discover something else in the vicinity that to some extent is even more mind-blowing, also proves a major idea behind cosmology, but also presents us with a new mystery, something in regards to the dark energy that we still don't really understand. So yeah, hello wonderful person, this is Anton. Let's discuss this new discovery that in essence potentially looks something like this, with this humongous bubble representing one of the fundamental assumptions of modern cosmology. And that by itself is a huge discovery. Currently, this new bubble is known as Ho'oleilana, a bubble that seems to encompass a lot of various superstructures, including the famous Coma cluster, Hercules cluster, Sloan Great Wall, Bootes supercluster, and of course the very famous Bootes Void. And in case you're wondering, the name Ho'oleilana refers to a Hawaiian creation song that symbolically describes this unusual structure. But before we talk more about exactly what this is, we basically have to take a few steps back and go back in time billions of years ago, when the universe was just a few thousand years old. Now all of this today is based on various predictions from cosmology, and here we're talking about the universe pretty much before the cosmic microwave background became visible. In essence, right after the universe was created, it was basically filled with this very hot plasma. Inside this plasma, things were not entirely uniform, and a lot of these tiny fluctuations started to produce tiny overdensities where slightly more matter would accumulate over time. But because this is plasma and everything here is extremely hot, instead of collapsing into larger objects like stars, there was also a lot of pressure coming from radiation that would push a lot of matter away from it. And so even though some particles would try to combine, instead they would actually get repelled, creating these unusual ring-like formations in every direction. But all of this stopped within about 390,000 years, as soon as the universe cooled down enough and the light was able to pass through everything, allowing the matter to finally condense. And this is when things started to solidify into basically objects we know today. But these unusual overdensities remained over time and served as a kind of a foundation for a lot of different galactic structures that actually should still be visible today, at least in theory. So we technically expect a lot more galaxies in certain locations because of this overdensity. And based on the analysis from the last 2 decades, by looking at hundreds of thousands of galaxies, various scientific teams did actually discover an unusual overdensity bump that you're going to see right here on this graph that seems to correspond to a peak at approximately 500 million light years in distance. In other words, to try to understand this, it's basically a kind of a statistical analysis. if we were to look at various galaxies away from our own galaxy, the Milky Way, we're actually going to find quite a lot of galaxies at a distance of about 500 million light years away from us, but not as many at a distance of 400 or 600 million light years. All a result of these overdensities that existed or were predicted to exist in the early universe. Okay, I know this is quite a confusing concept, but in essence this concept is known as BAO, Baryon Acoustic Oscillations. And I think raindrops or water ripples visually represent this concept pretty well. But like a lot of other predictions in cosmology, these ripples actually grow in time because of the expansion of the universe. And so they were most likely much smaller in size billions of years ago when the universe was much younger. Which also creates a very intriguing way to measure the expansion of the universe by using what's known as the acoustic scale. Basically, there's a kind of a distance correlation between the expansion of the universe and the overall size of these baryonic oscillations. And well, according to modern calculations, today this distance is supposed to be almost 500 million light years. And it was naturally much smaller in the younger universe. Now this is based on both predictions and of course calculations based on various surveys that were specifically designed to study all of this. And quite a few of these surveys seem to have come to the same conclusion of approximately 500 million light years. Once again visible at the best in this graph. And so these unusual peaks and valleys produced by the matter itself are one of the most important predictors of the entire cosmology, and also to some extent prove both the existence of dark energy and the unusual phenomenon known as dark matter. And as you've probably guessed by now, this is exactly what was just discovered pretty much in our neighborhood. Potentially the first local BAO, Baryon Acoustic Oscillation. With all of this based on an extremely recent survey known as Cosmic Flows 4, a study of nearly 55,000 galaxies in order to try to figure out the mystery of dark energy and to obviously also map all of this. But in the process, scientists behind this study, completely by accident, possibly discovered something really amazing. Something that in cosmological terms is right in our neighborhood. And something they were definitely not looking for. It was discovered entirely by looking at the data containing densities of various galactic clusters. And turns out that there's definitely some kind of a higher density that seems to appear in a circle, or technically a sphere, that's approximately 1 billion light years in size. And the only explanation for this unusual formation is that it is definitely one of those BAOs, one of the oscillations produced by the early universe. And since this is the most accurate data so far, at the moment it's kind of difficult to doubt this or to think that this is wrong. But assuming that this is correct, there are already a few problems here that nobody can solve right now. First and foremost, it seems to be much closer than anyone ever anticipated, which already means that the universe could be expanding much faster than we believed. And more importantly, its size is much larger as well. The predicted size is approximately 490 million light years, but the diameter here is at least double. It's just over 1 billion light years from one end to another. But assuming once again that this is correct, this is basically the first time ever we actually found an individual BAO structure that we can identify anywhere in the universe. All of the previous attempts and previous discoveries were mostly based on statistical analysis and just showed us that they exist, but none of them were ever seen as actual structures. And so in some sense, these unusual bubble-like structures are actually super important in helping us understand the evolution of the entire universe, the expansion of the universe, and also the distribution of dark matter. And so for a lot of cosmologists out there, this is maybe one of the biggest discoveries of the last couple of decades, if not longer. A direct physical confirmation that baryon acoustic oscillations exist, and there's one right next to us, and a direct way to study these oscillations to learn more about the universe. With the analysis also adding to what's known as the Hubble tension, or essentially that we don't really know how fast the universe is expanding, because the values seem to be different depending on where you look. You can learn more about this in one of the videos in the description. And so since the original statistical detection back in 2005, it only took about 18 years to potentially discover one of these objects, or these superstructures, right next to us. And so hopefully this discovery will help us understand the nature of dark energy, constrain a lot of cosmological parameters, and help us figure out where all of this is headed and also how all of this started. But exactly what scientists discover from this and exactly what this means, we're not going to know for at least some time. Hello wonderful person, this is Anton, and well, first of all, as you might have noticed, there's a microphone in my face and I'm basically trying something new. Second of all, we're discussing something really exciting, at least for astronomers and for physicists. We're discussing a detection of the second most powerful cosmic ray ever detected. The cosmic ray that now even has its own name. It's known as Amaterasu, named after the Japanese god of the sun. But in this case, what makes this even more mysterious is not the discovery itself, but where this unusual cosmic ray came from. It sort of came from nowhere, or basically the middle of empty space, in the middle of the least dense region in the nearby universe. It came from the local void, one of many voids out there where we usually find practically nothing. There's definitely some stuff here, but not a lot of galaxies. And so let's discuss these mysteries in a little bit more detail, but also let's actually talk about why this is sort of important and how all of this was discovered as well, because the story here is kind of interesting. It starts with Father Wolf, Theodore Wolf, a Jesuit priest who developed a device known as electrometer, whose main purpose was basically measuring production of ions inside a certain compartment. And he was the first person ever to do something really cool. He took his device to the base of the Eiffel Tower, and then he took it to the top of the tower. In a process going something like, "Ooh la la, this is so cool," and basically establishing that, for some reason, radiation on top of the tower was just a little bit higher. He also did another measurement, discovering that it was much lower underwater, eventually coming to a conclusion that there is some sort of a source of ionization or radiation from outside of planet Earth. This was back in 1909, so this was just over 100 years ago. And these experiments were later repeated in the upper atmosphere, including one in 1912 on top of a balloon. Naturally, the radiation would increase even more. But even though most scientists assumed that it was the sun, when this experiment was repeated at night and the same was discovered, the sun was out of the picture. The radiation was coming from somewhere else. All of this was discovered and confirmed by Victor Hess, a German physicist who eventually won the Nobel Prize in 1936 for discovering cosmic rays. And eventually scientists realized that all of these cosmic rays seem to be extremely fast-moving particles, mostly protons, but also at least 10% are helium nuclei, also known as alpha particles, and about 1% are much heavier elements such as carbon, iron, and even lead. But even after decades of studies, nobody had any idea where all of this is coming from. It couldn't be just coming from typical gas or typical nebula. Because the velocities here were so high, close to about 99.99% of speed of light, these particles had to be the result of something very powerful. And though it was believed to be maybe supernova or possibly similar explosive events, some scientists believe that maybe it was actually black holes. And some of the more recent discoveries also established the importance for the heliosphere and the region known as the termination shock. It actually seems to act as a shield and a barrier, protecting us from over 90% of these very powerful emissions. In other words, if the sun weakens, which it has done in the past, it sort of decreases the protection from all of this extra radiation from the outside, thus dramatically increasing the cosmic rays that can easily reach the planet and thus overall increasing the radiation in the process. Although Earth's magnetosphere also plays a role in protecting us as well. It does deflect certain cosmic rays, preventing them from reaching the surface, which has been discovered because there is a very different flux or different levels of emissions depending on the longitude and latitude where the observatory is located. So there's definitely a lot of complexity when it comes to magnetic fields and the interaction with the sun. But the overall energy density of cosmic rays seems to change with time for other reasons as well. We still don't really know why, but observations from previous studies suggested that every few thousand years the levels increase or decrease by at least a few times. It may be due to solar activity, or it may be because the solar system travels through various regions of the galaxy. At the moment there is really no exact explanation. But in terms of the total energy density, it's not super high. It's kind of comparable to the total energy density of visible light from various stars out there, not including our sun, and it's also comparable to the cosmic microwave background. But once in a while, some of these cosmic rays can be a lot more powerful than other cosmic rays. Also, fun fact, you might be aware that cosmic rays affect us directly in a lot of different ways, but I think the most surprising is computers. IBM actually did a study back in the 90s suggesting that a typical computer will experience approximately 1 cosmic ray induced error per 256 megabytes of RAM every single month, implying that the total error rate does actually add up to significant levels, especially for things like servers. And this is why back in the day someone invented what's known as ECC RAM, which is supposed to protect computers from all of this data corruption. And there are quite a lot of other stories, including stories of various NASA probes malfunctioning because of all of this. But basically, in a nutshell, this is a legit phenomenon that needs to be understood and needs to be studied more. And though regular cosmic rays are pretty well known to us now, we still don't really understand what forms most of them. But it's really some of the more recent discoveries that sort of surprised everyone. For example, the discovery of very powerful cosmic rays, sometimes referred to as pivatrons, which is basically a kind of an acronym based on their power, peta-electron volts. And here, these seem to come from relatively similar directions. So scientists believe that there are these pivatron factories that produce cosmic rays of extremely high energy. These are probably supermassive black holes. And there actually seems to be at least one in the middle of our own galaxy as well. But most seem to be coming from the famous Centaurus A galaxy, essentially the nearest active black hole relatively close to the Milky Way. But there's at least one paper in the description below that talks about a discovery of these unusually powerful cosmic rays coming from a region possibly even closer. Here we're talking about Cygnus Cocoon, or a stellar nursery 4,600 light-years away from us. It's not entirely clear why these powerful emissions are coming from here, but basically this means that something is accelerating particles to ridiculous velocities. This could be related to very powerful magnetic fields, or possibly some kind of an intermediate black hole hiding somewhere in the middle. Although here this paper made another somewhat surprising discovery. It turns out that when it comes to most particles, so here we're talking about hydrogen, helium, carbon, and so on, they mostly seem to travel in a relatively similar direction. But for some reason, not iron. Iron cosmic rays seem to arrive to Earth in a different way, because nobody knows. It's still a mystery and there's no explanation. But so far all of this could be explained. This, though, is very difficult to explain. And all of this started in 1992, the discovery of Oh My God particle. The discovery of the cosmic ray so powerful that it made absolutely no sense. And this wasn't in peta-electron volts anymore. It was at least several thousand times more powerful. It was now in exa-electron volts. A cosmic ray so powerful that here, a single particle was basically moving with the kinetic energy of a baseball. If something like this passes through you, yeah, you're gonna have some major DNA damage. I mean, obviously it's not gonna kill you, but it's basically like having this tiny particle shoot through you at ridiculous velocities. Okay, I guess I'm being a little bit too extreme here, but I wanted to kind of give you an idea of how ridiculously powerful this particle was. And the thing is, it just does not make any sense. We have no idea how something like this could ever be produced. But turns out that more and more of these exa-electron volt particles started to be discovered in the last few years. And they now have a name: ultra high energy cosmic rays, UHCRs. Yeah, quite a few have been discovered in the last few years, but they all seem to come from very specific regions in the entire universe. The overall map kind of looks like this, and it basically suggests that there are these hotspots where all this seems to be concentrated. Now at least one of them seems to be once again close to the Centaurus A, and the other one seems to be located possibly close to the Messier 87 or M87. But that's still preliminary because there are a lot of objects in this region, and it could be coming from much farther away. But interestingly, scientists today believe that they cannot come from too far away, and there's a really intriguing phenomenon behind this. It's known as GZK limit, a limit that's a result of a lot of other radiation in outer space, including things like the cosmic microwave background. And so basically here the idea is that if something is moving at ridiculously high velocities, the interaction with the CMB is actually going to start slowing down this particle over large distances, usually around 160 million light years. And so if something comes to our planet with very high energies, it has to come from less than 200 million light years away from us, at least according to this particular explanation. Which is why Centaurus A and M87 have always been the biggest culprits. but they don't seem to answer the questions behind the most powerful cosmic rays. For example, the oh my god particle did not come from either one of these. Neither did some of the other detections from the last few years. And to try to solve their mystery, for the past few years, since 2015, NASA has been collecting data about all of this using what's known as CALET, Calorimetric Electron Telescope. And it's already collected data for over 7 million particles since 2015. And it already made a somewhat unusual discovery. It was assumed that at higher energies, we're going to be seeing less of these particles. Basically, it's a kind of a distribution with the more energy, the less particles. Turns out it's actually the opposite. There seem to be more high energy particles compared to low energy particles. Nobody knows why. But then, in May of 2021, it detected something that looks like this. And this was something very, very powerful. And obviously something nobody expected. This was basically Amaterasu, the second most powerful cosmic ray ever seen, with the energy of 244 exa-electron volts. Way more powerful than any other previous detections, and once again about 100,000 more powerful than a typical pevatron, but a little bit less than the OMG particle. Here we're talking about 244 versus 320. Or a tennis ball compared to a baseball. And this implies that these particles seem to be definitely real, it was not a fluke, and represent a new cosmic phenomena. Some kind of an exotic astrophysical event that currently makes no sense. And this one makes no sense because it came from here. There is kind of nothing here. I mean, there's something, there's like maybe 6 galaxies, but they're all tiny, none of them are active, none of them possess tremendous supermassive black holes, and definitely none of them possess the ability to create something that's so powerful. And so one possibility is that maybe it actually changed directions because of magnetic fields, and in reality it came from somewhere else. But when it comes to a cosmic ray that's so energetic, it is very difficult to change its direction. It's actually super unlikely that it was veered off by some kind of a magnetic field by more than a few degrees, so it still most likely came from the local void. And as far as we know, there is nothing super energetic hiding inside the void. And based on that limit I mentioned, it must have come from within 200 million light years. And as far as we see, there's just empty space there. And so based on this speed limit of the universe, and based on the fact that these particles don't change direction too much, we essentially have this unusual cone where it most likely came from. But none of the modern telescopes are detecting anything from here. And so there you go. That's the new mystery. No accepted explanation just yet, but there are some preliminary explanations that potentially might solve some other mysteries. For example, maybe this is actually a result of dark matter annihilation. There's definitely dark matter in this region, and so maybe all of these super fast moving particles are actually produced in somewhat unusual ways through a phenomenon we've been trying to discover for many years now. Alternatively, maybe all of this is actually coming from much farther away, so basically way behind the local void, and this whole limit thing we thought was real might not actually be real after all. So maybe this is actually coming from like the edge of the universe, and there is something here super powerful, which by itself would be even more mysterious, but whatever it is, we're just not seeing it yet. Either way, this is probably one of the more exciting discoveries in the last few months, and so exciting as a matter of fact that once again, it has a name, Amaterasu. And though it might lead to a discovery of some kind of a supermassive black hole in this region, it's definitely none of the usual culprits. Not M87, not Centaurus A, something entirely different. But what we'll discuss in some of the future videos once someone points the telescope at this location and finds what it is. Maybe we'll actually find something really cool hiding right in the middle of the local void. By now you might have heard the news about the planet known as K2-18b, the very strange Hycean world simulated right there behind me, that potentially resembles a very strange water world with a very thick hydrogen atmosphere, relatively hot conditions, and very likely a large ocean on the surface. But the water in this case is maybe not liquid, and is probably in supercritical state, very similar to what we find around hydrothermal vents deep in the oceans. And as we've discussed in one of the previous videos that should be in the description, an extremely recent analysis using the data from James Webb Space Telescope was able to produce a relatively accurate observations of what's happening in the atmosphere of this unusual, exotic world. And though some things we kind of expected, such as methane and CO2, some were very unexpected. DMS or dimethyl sulfide. a gas that here on Earth has always been associated with life. It's a biosignature. And so in this video I wanted to go through some more details in regards to this gas, what we actually know about its presence on potentially other planets, and most importantly, talk about how likely this detection means that there's life on this planet. Is this the first discovery of alien life anywhere? Or is this maybe just another LK-99? Remember that superconductor that went nowhere? Yeah. So basically let's talk about how scientific is this and how accurate are the results. But before we talk about the paper and before we talk about anything else, let's really discuss the gas first. A gas, dimethyl sulfide, that's recently been studied for a very different reason. It's actually one of the biggest contributors of various types of sulfides and specifically atmospheric aerosols on our own planet. Or to be more specific, when it enters the atmosphere, it seems to do several things. First, it encourages formation of clouds, and second, it releases sulfur aerosols, which normally reflect sunlight, basically serving as a kind of a reflector for planet Earth. Which is why so many different environmental scientists have been really interested in what exactly is happening here. But as I mentioned in the previous video, it's really only produced by life. There is no natural way we know of that produces this gas. A gas whose molecule looks like this. Sulfur, 2 carbons, and 6 atoms of hydrogen. And so I really wanted to find out, is there any way it can be produced naturally, as in without life? Do we have any evidence of the production of this gas through, for example, volcanic means? And pretty quickly the answer turned out to be no. Volcanoes tend to produce different types of sulfur compounds, and there's no way they can produce DMS. And it turns out that dimethyl sulfide seems to be extremely common in locations like this, where you can kind of see what's known as red algae. With quite a lot of different ocean organisms, specifically marine plankton, consuming what's known as DMSP or dimethyl sulfide propionate, a slightly more different organic compound, which is then converted to DMS as a type of a waste product. With this gas DMS potentially being the biggest waste product for most of the algae and most of the simple marine organisms out there. With this precursor, DMSP, usually breaking down this compound into one of two forms, either DMS or a slightly different compound known as methane thiol. Both essentially only produced by life, representing a type of biosignature, with neither produced in any other natural way, except for obviously chemical labs. In this case, DMS is actually produced by various labs for different chemical purposes. But this type of a chemical reaction does not seem to exist in nature, at least on planet Earth. And what's actually interesting about DMS is that there doesn't seem to be the upper limit for how much can be produced by various marine organisms. As long as there's enough sulfides coming from outside, DMS is going to come out as a waste and released into the atmosphere. Implying, of course, that more DMS means more marine life, at least on planet Earth. But what's really important here is that this is not a very stable compound. It will usually react with hydrogen to form methane or sometimes hydrogen sulfide. Interestingly, quite a lot of methane was discovered on this planet as well. Though by itself, neither methane nor hydrogen sulfide suggest life. They can be produced in natural ways as well. And so because of the production of DMS only by life, for many years it was implied to be one of the potential biosignatures. And I actually managed to find some of the first papers that talk a little bit more about this in more detail, and 2 of them are by the very famous scientist from MIT, Sarah Seeger, a Canadian astronomer that's been extremely active in trying to figure out ways we can discover life on other planets. She's also a very big proponent of returning to Venus to potentially find life there as well. And so in a couple of papers, Seeger and her partners discuss various biosignatures that in theory could be found around certain planets hosting atmospheres with potential signs of water on the surface, with the original paper proposing DMS as one of the biggest biosignatures that we can find around various planets, going as far as establishing what we might see if we look at these planets in various frequencies. They essentially create a kind of a spectroscopic graph for different types of planets, including planets with hydrogen, planets with nitrogen, or planets with CO2. Although here they only focus on 4 biosignatures, the ones you see right here, and the ones that we usually associate with life on planet Earth. And interestingly enough, in their analysis, they actually realized that it also depends on the star. If the star is very powerful and produces a lot of ultraviolet radiation, it's quite likely that we're going to find nothing. A lot of these molecules would be destroyed pretty quickly. But much smaller stars, and especially M-type stars that are somewhat quiet, would very likely produce positive results as long as there is life on those planets. And specifically, because DMS is what's known as a product of secondary metabolism, by seeing this in a planetary atmosphere, it's extremely unlikely that it's going to be produced by anything else. At least compared to a lot of other biosignatures, such as for example oxygen or methane, which can be easily produced by other means. And so we actually call this a type 3 biosignature. It's a product of consumption of something else, and at least in various types of zooplankton, is normally produced as a response to stress when the more complex DMSMP gets broken down by various types of enzymes. And this has been tested in a lab when the introduction of DSMP results in huge amounts of DMS being produced. But the thing is, on Earth, DMS disappears very quickly. It only has a lifetime of just a few days. It basically breaks down, eventually turning into sulfide oxides. And it's really those sulfide oxides that then act as aerosols. But on a different planet, possibly orbiting a red dwarf, there is a chance it might survive much longer, and thus be much more abundant in the atmosphere. Intriguingly, that's precisely what's actually observed here as well. Even though DMS is only present in somewhat minute amounts on planet Earth, on K2-18b it seems to be all over the place, or at least seems to be present in large amounts, according to that recent paper. And interestingly, previous predictions by Sarah Seeger from the two papers I showed you previously predicted a potential existence of hydrogen-rich planets that might be extremely abundant in DMS because of a relatively large biomass of a lot of different primitive life. To some extent, this is maybe what's being observed here as well. And so these unusual Hycean planets or Hycean worlds, planets containing a lot of hydrogen and potentially liquid water, in some sense would be perfect places to try to investigate if this gas exists in their atmosphere. Especially because these planets are much easier to analyze and to look at compared to rocky planets, meaning that James Webb can come to much more conclusive results much quicker. Which in essence is what happened here. We have a very strong detection of methane and a very strong detection of carbon dioxide. Here the confidence level is 5 sigma, basically implying that it is maybe 0.001% by chance. And intriguingly, no detection of ammonia, which turns out to be one of the predictions from back in the days. Prediction of ocean worlds containing hydrogen atmospheres, where ammonia would disappear because of chemical reactions, with quite a lot of predictions potentially coming true from these observations. Or at least it seems so at first, because now we have to talk about the biases and the but wait. So essentially let's dissect this and let's try to come to a conclusion of what is really happening on this unusual planet. First of all, let's discuss the bias. The same professor who published this recent paper also published another one just a couple of years ago with the title that you see right here, Habitability and Biosignatures of Hycean Worlds. And as you can probably guess, that paper tried to predict what we're going to see around these planets, focusing on the discovery of biosignatures such as DMS. It wasn't the only compound, but it was definitely one of the main ones. If you read through the recent paper, you'll notice that this particular older paper is referenced quite a lot, which usually for me at least is the first stop sign. Okay, so basically, is this a kind of a confirmation bias? The researcher predicted something, and now he or she is trying to confirm it using observations. Now, it might seem that way, but it usually depends on the quality of the data and the exact discoveries made in that study. So let's go with that. Let's see what was actually found here. In this case, this was analyzed using probability in order to confirm how likely are we seeing what we're seeing. You can actually see that for methane and CO2, it seems to be extremely likely. Once again, here the evidence was approximately 5 sigma. But for DMS, it's definitely not so clear-cut. And for other biosignatures, it seems to be an almost certain no. As a matter of fact, the authors themselves state the obvious. The confidence levels for DMS are super low. The authors themselves state this as a marginal evidence, with a significance level of anywhere from 1 to 2.4. For one of the results, they even get 0. And usually anything below 3 in significance is not really worth considering. To some extent, you can even see this in the image released by the team from the James Webb. DMS levels are barely visible. It's not even clear if this is DMS or if it's something entirely different that just happens to have similar spectroscopy. As you can see, the authors even provide you with a graph to show us that it's not clear exactly what this is. And so the authors state that they find some evidence of DMS depending on how you analyze the data, but the actual significance depends on further observations in the future. One of the main reasons it seems to be so difficult to confirm this is because the spectral values for DMS seem to resemble other molecules as well, at least in near-infrared observations conducted by the James Webb, with the main conclusion in this case being that we now need to conduct additional observations in other frequencies that seem to be already planned for the next few months. As a matter of fact, DMS seems to have a very specific spectral signature around 7 micrometers. This should definitely be visible with future observations using mid-infrared frequencies by the James Webb. And so chances are we're not going to be able to confirm anything here for at least a few more months. Which means that there are going to be two possible answers. Either nothing is confirmed and this was a mistake, or DMS is confirmed, suggesting something is producing huge amounts of this unusual chemical on the surface of this planet. Here we're talking about millions of times more than on planet Earth. And though this could be some kind of a extraterrestrial life, it could also be some kind of a chemistry we still don't understand. And so at least as of today, as of September of 2023, the answer is nobody knows. It's still unclear, the actual observations and the actual details are not super detailed, and the levels of confidence for data is extremely low. So this planet definitely seems to contain methane and quite a lot of CO2, but everything else at this point is not certain. Hello wonderful person, this is Anton, and today we're going to be discussing a somewhat intriguing discovery of a very unusual white dwarf that seems to show direct evidence for what the scientists refer to as white dwarf crystallization, or essentially signs that this particular white dwarf is slowly turning into a massive crystal. And because it contains a lot of carbon on the inside, in the past press has actually compared this to a massive diamond, possibly similar to what you see right here. But that's of course just an artistic or even symbolic interpretation. In reality, crystallization inside these white dwarfs is a much more complex process. And so in this video, let's actually discuss a little bit more about this particular discovery, how all of this was discovered, and what this means for astronomy. But it's important to start with a bit of an overview, especially because our sun one day is most likely going to become something similar. So today we know that stars that are less than 8 solar masses in mass will not go supernova, and instead will end up expanding a lot, produce what's known as planetary nebula, the concept that you can learn more about in one of the videos in the description, and right in the middle, as you can see from this image, leave behind a white dwarf that's actually responsible for the ionization of the gas that creates these beautiful formations. And it just so happens that one of the closest stars to us, Sirius, contains one of the more interesting white dwarfs that you can see right there. We've discussed the system and what the scientists discovered here in one of the videos you can find in the description. But I guess here the question is, so what exactly is a white dwarf? I mean, in a nutshell. Anton, explain it to me like I'm 5. Well, it's basically a core remnant from a star that lost its outer shell. But because this is a stellar core, it's also extremely dense and contains a lot of material inside that's been squished by everything that used to exist above it. But it's a core that does not produce any more energy, and all of this extra pressure and extra density creates conditions where electrons start to create their own sort of ocean. But because electrons are particles that are not allowed to be in the same state in the same amount of space, they create a kind of a external pressure that we refer to as electron degeneracy. This prevents the white dwarf from collapsing even further, and basically maintains its shape and its mass up until it reaches a kind of a limit. This limit is usually around 1.4 solar masses and is referred to as Chandrasekhar limit. When that limit is reached, that's when the star can no longer sustain itself and basically explodes in what's known as Type 1a supernova. The supernova that usually produce around the same amount of energy because they always explode around the same mass, which is often why they're used as a kind of a distance candle to measure distances to various faraway galaxies. But they have to get that mass from somewhere, and usually they basically steal it from one of their partners. But this doesn't always happen, and sometimes the white dwarf is really far away from the partner, kind of like in the system of Sirius, in which case that white dwarf is going to age and change its properties because it's essentially cooling down over time. And so even though it starts extremely hot because it used to be a core of a star, and it actually starts really hot, producing a lot of very bright white and blue light, over time it cools down, slowly becoming reddish, and eventually it's supposed to turn black. And so the ultimate fate for all white dwarfs and essentially all stars like our Sun is to become some kind of a black dwarf, producing no more light. But that takes a really long time, possibly trillions and more likely quadrillions of years. The universe is only 14 billion years old, so today nobody expects to find any of these black dwarfs, simply because the universe is relatively young. Finding a black dwarf would be a huge deal and would most likely disprove a lot of modern cosmology, but because we haven't found any black dwarfs anywhere, at the moment it basically suggests that Big Bang most likely happened, and overall, the age of white dwarfs seems to actually imply that we have the age of the universe calculated more or less correct. But the main point is that these stars do evolve over time. And part of this evolution involves the process of crystallization, when some of the ions inside the white dwarf start to freeze and acquire a kind of a crystallized pattern. But as white dwarfs crystallize, they also release a little bit of energy, which basically implies that they can actually maintain their temperatures just a little bit longer. And so all of this unusual electron ocean on the inside starts to assume a kind of a permanent shape, with all of the complex elements inside eventually crystallizing into one single massive object. But the obvious question is it actually a diamond? The answer here is, well, not really. Mostly because diamonds, which is of course carbon, have a much lower density. Here we're talking about density that's like possibly 1,000 times lower. Whereas white dwarfs very likely contain a very different type of carbon that most likely has very different properties that we can't even imagine. But I guess interestingly, this process of crystallization does not seem to take as long as turning into an actual black dwarf. Because it looks like we've discovered at least one star out there that definitely shows signs that it's being crystallized from the inside. A star system that we used to think contains 3 stars, this is a star system known as HD 190412, but that seems to contain another object that we've discovered very recently with the help of the iconic ESA's Gaia telescope. And more importantly, this telescope also allowed the scientists to extremely accurately determine the orbits and also determine the age of the system, with the system appearing to be pretty old. The 3 stars orbiting here appear to be about 7.3 billion years old, but the 4th star, the white dwarf, appears to be only 4.2 billion years old. And so there's actually an almost 4 billion year discrepancy. And though it's obviously possible that the white dwarf came from somewhere else, based on the observed orbits and just based on the fact that it's very unlikely, the scientists believe that all of these stars were very likely formed around the same time. And the fact that the white dwarf appears much younger implies one thing. It actually implies that it produces way more heat than it should, with the heat extremely likely being produced by the process of crystallization. Or essentially, as the carbon and oxygen atoms inside this white dwarf stop moving around and start forming crystallized forms, they actually slowly release energy that heats up the white dwarf even more, allowing it to release just a little bit more heat than usual. And all of this is visible as a very specific color signature coming from the white dwarf. Something that has been theoretically predicted before, but something that has never been observed. As a matter of fact, there's even a paper predicting all of this back in the 60s. You can find that paper in the description below. And so crystallization inside this white dwarf is really the only way the scientists can explain a huge discrepancy in the age of these stars. But I guess more importantly, the fact that this particular star system is so close to us, and the fact that it's already crystallizing, producing the cooling delays as predicted by various models, implies that these objects must be really common. Or in other words, crystallizing white dwarfs probably exist all over the place, it's just this one is the first we've discovered so far. But here the scientists have also discovered a bit of a discrepancy, specifically a little bit more heat than predicted. They don't exactly know why this is happening, but they believe it's possibly because of the isotopes of neon, located inside the core of the white dwarf, with the isotope potentially producing a little bit more heat and thus delaying the cooling even more. In other words, the scientists did not actually expect to discover so much heating or so much delayed cooling, with the crystallization process being extremely efficient and potentially producing way more energy than expected. But because of the similarity to the famous Sirius system, the scientists now believe this is a pretty common phenomenon. Hello wonderful person, this is Anton, and today we're going to discuss a relatively intriguing study that confirms something super unusual about distant universe. But before we talk about the study, let's start with the somewhat hypothetical scenario in order to actually understand what all of this is about. So imagine for a second that we had a really large and a really powerful telescope, way more powerful and way larger than the James Webb. And so imagine we had a telescope that's able to zoom in on really far away distances and easily observe various galaxies or even what happens in them at essentially the edge of the universe. And so for example, instead of just seeing one bright object, like a typical quasar that you see right here, it would suddenly start revealing these beautiful galaxies interacting, colliding, and even showing us star motion or even planetary motion in a lot of these super far away objects. Objects at distances of billions of light years, or essentially when the universe was only a few 100 million years old. And so the question here is, what exactly would we see from right here on planet Earth in the modern universe? Well, the first obvious answer is of course the redshift effect. Because of the unusual property that we refer to as dark energy that seems to cause the universe to expand and even accelerate its expansion, a lot of these distant galaxies and a lot of these distant objects would be extremely redshifted. For example, even though the galaxy might be somewhat bluish in color in modern universe, it would appear much redder, with some visible light actually only visible in infrared spectrum because of the redshift of optical light. And that's of course something that we actually use for measurement of different distances, and is something that's basically a fact, or has been a fact, for a few decades. And that's of course something that you might already know. But what many of us forget is that this is just one of the effects that Einstein proposed when he talked about the idea of redshift and blueshift. And specifically when it comes to dilation, which is exactly what this is, there's also the idea of time dilation. Which means that, at least in theory, these distant galaxies should not just appear redshifted, they should also appear moving in slow motion, much slower than anything around us. And that's essentially what this recent study is about. It actually physically confirms that this is indeed what seems to happen with a lot of very distant quasars, or a lot of very distant galaxies. They do seem to be moving in slow motion from our perspective here on planet Earth, and in some cases in very slow motion. And so let's actually discuss a little bit more about all of this, and I guess also let's find out why this is so, how the scientists discovered this. And so first of all, the idea of time dilation is of course one of the predictions of Einstein's theories. And so here, if you start moving faster and faster across the universe, at some point various frames of reference will start measuring time differently, with time moving a little bit slower for an object that's in motion compared to another object. Here's actually a really good example of something orbiting around something else. And we know that this is exactly what happens to various satellites orbiting the planet, which is why a lot of GPS satellites have to take dilation into consideration, otherwise they would become inaccurate over time. But for satellites, this is usually a very minuscule change. It's basically in nanoseconds per day. But for objects moving across the galaxy or across the universe, this does become quite prominent. And so even though some stars in the galaxy do move at thousands of kilometers per second, producing some dilation effects, once we start reaching the outskirts of the observable universe, the dilation effects technically should become extremely prominent, because here, due to the expansion, and due to the redshift observed, the velocities are extremely close to the speed of light. And some of these time dilation effects have been actually demonstrated by studying distant supernova. It just so happens that the more far away a supernova is from planet Earth, the longer it seems to last. And though it's possible for one or two supernova, statistically there does seem to be a correlation between the distance of supernova, the amount of redshift experienced by the supernova, and the total length of time. But even though theoretically it made sense, physically there was just maybe not enough evidence just yet. Nevertheless, this idea of redshift-dependent time dilation has always been super intriguing. Especially because by proving this, we're basically once again proving Einstein's general theory of relativity and some of its fundamental predictions in regards to distant universe. But obviously looking so far back in time has always been a bit of a challenge, although has become less challenging because of new telescopes. For example, in just the last couple of years, the scientists have actually discovered quite a lot of different quasars, with more and more discovered by the James Webb. As a matter of fact, in just the last few months, it's identified several new quasars when the universe was only 800 million years old. And some of these objects are very powerful and very massive. Here we're talking about black holes that are possibly 200 million solar masses in mass, with the biggest one being about 1.4 billion. But intriguingly, the relationship between the black hole mass and the galactic mass seems to be consistent no matter where you look. And so basically, the more massive the black hole in the center, the more likely you're going to have a more massive galaxy. Although obviously the only reason we can even see these objects is because of all of this material that creates huge amounts of friction around the black hole, heating up the material to millions of degrees, and creating some of the brightest objects in the entire universe. But once again, the intriguing question here would be, do these accretion disks spin in slow motion as predicted by Einstein's theories? Is there actually some kind of a time dilation that could be maybe discovered if we looked at enough of these quasars? And is this something that's physical and observable, or something that we might never be able to prove? So unfortunately, we obviously cannot see the physical details of these black holes and the accretion disks, and we're not going to have telescopes capable of doing so, or actually possibly ever. It will be an extremely difficult task. But we could use statistics and observations from various quasars to see what's actually happening here. So for example, things like brightness, which is a property that all quasars are going to possess, can be then used to track time. And by observing quasars over time, in different locations across the universe, it then becomes possible to see various correlations. And so here, by using 190 different quasars discovered in the last 2 decades, going back in time approximately 12 billion years, when the universe was just over a billion years old, the researchers were able to see definitive patterns. Specifically, the emissions coming from these quasars appear to be slowed down by as much as 5 times, basically moving in like 5x slow motion. Now, they obviously did not see things spinning or things moving around, but they were able to observe the amount of activity and changes in various quasars that usually change their brightness. And it just so happens that the farther away the quasar, the longer various events seem to last, with variability of quasars increasing the farther away they are. And though it's possible there might be some other explanation to all of this, and maybe the quasars were just doing things much slower back then, in reality, because all of this seems to directly connect to the Einstein's theories, and more importantly is also directly related to the redshift of these quasars, at the moment this does seem to be the best evidence we have so far. Basically confirming that things do move much slower in time if you look at it from our time frame, with things moving in slow motion, as if they were actually moving at these very high velocities. But here it's, I guess, also important to add that this is from our time frame. This is all based on individual time frames and is not an objective reality at all. As a matter of fact, there is no objective reality, and it's always about these relative spaces and relative times that we always have to consider when thinking in cosmic terms. And so technically, even looking at the Milky Way galaxy from the top here is kind of misleading, because this galaxy is approximately 100,000 light years across. And so whatever happens on the right side of the galaxy is not going to be witnessed by the left side for at least 100,000 years. And so for our human brains, with our human experiences, this is not a very easy concept to understand. More so when it comes to the entire universe and objects that are like 12 billion light years away from us. Nevertheless, the evidence seems to be there, and it does suggest that, once again, Einstein was correct, and the distant galaxies that are redshifted are also, technically, moving in slow motion, or the time there seems to flow much slower. But the obvious question that I cannot answer right now, or I guess nobody can, is if it has any physical effects on the universe right here. Does this time dilation in any way affect the modern reality? I mean, it probably doesn't, but I guess we'll find out in time in some of the future videos. Hello wonderful person, this is Anton, and today we're going to be discussing some of the new discoveries in regards to the destruction of various stars that very often results in extremely powerful emissions we refer to as gamma ray bursts. But in this case, we're going to be focusing on a relatively recent study that, for the first time ever, seems to have discovered a completely new way for stars to be somehow destroyed. Something we've never seen before anywhere, and something that nobody could even predict up until this recent observation. And so in this video, let's actually discuss a little bit more about this very unusual event, explaining exactly what this event was, and more importantly, connecting all of this together and essentially trying to figure out what all of this means. But I guess first, The study behind this is, as always, in the description below. And the main point of the study was to try to figure out somewhat unusual properties for a gamma ray burst that was detected back in 2019. And when it comes to gamma ray bursts, most models today believe that it's something that looks like this. It's essentially a collapse of a relatively massive star that starts within the star with two very powerful rays bursting from two directions as the star goes supernova. And the resulting rays are so powerful that as they pierce through various clouds around the star, they essentially start producing various frequencies. But normally these events don't last very long. This is something that might last a couple of seconds or even less, although as you might have learned from one of the previous videos in the description below, some of these gamma ray bursts, especially more unusual ones, seem to actually last much longer, sometimes even several minutes. But these are extremely rare and very often involve something very extreme on the inside. Nevertheless, most of the gamma ray bursts so far have been basically below 2 seconds. And back in 2017, by studying neutron stars, we also discovered that the collision of neutron stars also results in a gamma ray burst, but in this case extremely short one. And because these are basically some of the most powerful explosions in the entire universe, trying to figure out what exactly created them, and doing so by observing those events in various frequencies, in the last years has become a priority for a lot of different scientists. Mostly because it would solve a lot of mysteries and help us understand the universe a little bit better. But apart from more extreme examples that we've discussed in previous videos, some of these bursts look relatively simple and somewhat usual, but sometimes turn out to be something very special. And that's pretty much what happened in this case as well. And here, the team behind the study wanted to use various observatories, including the Nordic Optical Telescope, the Hubble Space Telescope, and the International Gemini Observatory, to try to figure out what happened in this case, because it was just a little bit unusual. A little bit longer than it should be. According to the analysis here, it was obviously not the longest GRB, but it was sort of pushing the limits. But in order to try to figure out what happened here, the scientists first had to locate this particular event by discovering the original galaxy. And so by using the images from the Hubble Space Telescope, they were able to discover the original galaxy at a distance of about 3 billion light-years away from planet Earth. And this galaxy was somewhat quiet, not particularly active, barely visible, and technically is not an expected location for these very powerful events. These types of powerful supernova are extremely unlikely to happen in a galaxy that's somewhat old and somewhat quiet. You would expect this from a much younger, much more active galaxy, or a galaxy that's undergoing an active collision. And more intriguingly, this particular event seems to have happened extremely close to the center. A further analysis established that it was actually about 100 light-years away from the heart of the galaxy, or practically on the outskirts of the central supermassive black hole. And that was very strange. Extremely strange. Almost impossible to explain with a typical supernova. And it was only after follow-up observations that they also realized that this was unlikely to be a supernova or a massive star collapsing. There was no sign of any kind of supernova emissions or any kind of supernova remnants. And so if not a collapse of a star and if not a supernova, then what? Well, the only explanation that currently makes sense involves a catastrophic collision between two compact stars. But unlike neutron stars that would usually orbit around one another for quite a while before colliding and before creating a powerful gamma ray burst, in this case, it was most likely an almost head-on collision. An event so powerful that we barely understand it at all, and the event that most likely annihilated both stars, created the gamma ray burst observed from planet Earth, but possibly also left behind some kind of a black hole or maybe a neutron star. As a matter of fact, it's actually unknown what was left behind. But assuming that this is correct, it basically presents us with yet another way for stars to completely destroy themselves, meeting their final demise. Or I guess technically the fourth official way in which stars can disappear or transform into something else. Just as a quick reminder, the 3 other typical ways for stars to do this involve either going through the planetary nebula stage, releasing the outer shell and leaving the white dwarf behind. This is what's going to happen to our Sun. A supernova event, where the star collapses, releasing a huge amount of energy, leaving behind a neutron star or a black hole. This is what's going to happen to Betelgeuse. Or collision of various stellar remnants, such as neutron stars or sometimes white dwarfs, which very often results in an explosion as well, and in the end produces some kind of a black hole. And so it looks like now we have 4 options, with the 4th option being a direct collision at relatively high velocities. But the question is, of course, why do the scientists believe so, and how can such an event even happen? Well, the results here indicate that this must have happened in an extremely dense environment very close to the central black hole. Here are the actual images from Sagittarius A star vicinity, and you can see there are a lot of different stars orbiting around this invisible, extremely compact point in the middle. And based on various observations, today the scientists believe that there are a lot of different very dense objects in this region, including of course neutron stars, including black holes, but also some of the more unusual objects such as G objects or S objects we've discussed in videos in the description. Either way though, a lot of these objects are close enough to one another to potentially sometimes interact. And a lot of previous explanations for a large amount of black hole collision and neutron star collision detections we've seen so far involve these central regions. Quite a lot of scientists today believe that many of these black hole collisions very likely happen in these dense regions. Otherwise, we would not be seeing that many so frequently. And it looks like sometimes, in some of these galaxies, some stars can accidentally collide because their orbits eventually cross. And these central regions for a lot of these ancient galaxies are actually believed to contain quite a huge number of these stars that might have been here for millions and billions of years. But if this assumption is correct, and if this is indeed what happened here, this might also imply that many of these longer GRBs, especially previously unexplained longer GRBs, potentially share the same origin. Many of them might have actually been a result of a collision of two stars, but because of the distances involved, in many cases it will be difficult to establish if there's anything left behind. But in this case, because this is an ancient galaxy and because it's not very active, observing the central region here was a lot easier than before. And so technically this is the first observed event that involves stellar collision from what seems to be a very crowded environment inside the central region of a galaxy. But if we can also detect some kind of a gravitational wave connected to this event, that could definitively help scientific teams to answer a lot of the questions. At the moment, no such gravitational event was detected so far, and only future similar events happening in various galaxies could maybe help us determine if this is what's going on. At the moment, this is definitely a very exciting explanation and a very exciting detection, which of course also means that star collisions, and especially powerful star collisions, are probably a lot more frequent than we ever believed and do result in some of the most powerful explosions in the entire universe. Although surprisingly, no supernova, just a gamma ray burst. But we'll probably need a lot more evidence from a lot of future studies to determine all of this and to actually find out how frequent all of this is. Hello wonderful person, this is Anton, and today we're going to be discussing some of the preliminary scientific results from the DART mission that actually occurred only a few months ago, that, as you might remember, was responsible for redirecting a moon of a small asteroid by directly colliding with it at an extremely fast velocity, essentially allowing the scientists to finally figure out if this is a viable tactic for a potential redirect mission if there is some kind of a dangerous asteroid headed toward planet Earth in years to come. And as you might have learned from some of the previous videos, this was a tremendously successful mission, and the scientists were actually confused about why it was so successful. With the collision that was observed by several different satellites and several observatories on the planet, including of course the James Webb Space Telescope, resulted in things like a tremendously long cometary tail, approximately 10,000 kilometers in length, and moreover resulted in a redirect of the asteroid by a total value of approximately 30 times higher than what the scientists expected. Or to be more exact, the scientists here expected that the orbit of this moon would change by approximately 70 seconds. But instead it changed by approximately 32 minutes, suggesting that the effects from this collision were dramatically higher. And so that's kind of what the scientists were trying to figure out for the past few months, with some of the preliminary results explaining what might have happened. But intriguingly enough, a lot of these observations and effects to some extent were predicted in this paper that was published just a couple of weeks before the actual collision. We'll talk about this near the end of the video, because this provides a lot of the explanations for what might have occurred. And so first, what exactly is this asteroid? Well, Didymos, the larger rock, has a small partner known as Dimorphos. That's the one that NASA collided with. And in terms of size, appearance, and even composition, it represents a group of asteroids that the scientists believe have the highest chance to potentially collide with our planet in the next few thousands of years. A lot of the near-Earth asteroids, especially the ones that we haven't discovered yet, seem to have extremely similar parameters. This asteroid, along with many similar asteroids, is composed of chondrites, a rocky material formed from dust and relatively small pieces of rock that existed early on in the solar system and coalesced into these larger objects we refer to as asteroids. And so basically this is a collection of rubble, not necessarily an actual large rock. With pretty much most of the asteroids discovered so far, especially the more dangerous ones, generally possessing very similar properties. And in this case, both Didymos and Dimorphos seem to have very similar composition. This was one of the more recent discoveries. A lot of this was actually achieved by studying the reflection of sunlight from all of the ejecta following the collision, and by looking at how solar radiation stretched the ejecta into twin tails. And by then comparing this with known comets and a lot of other tails, the scientists were able to figure out what sort of a composition this has. But more importantly, this also allowed the scientists to figure out the total mass of the displaced material. Because even though the initial simulations suggested it's going to be a tiny explosion, with potentially a small tail, the reality was much different. Even though the craft itself was not particularly big, it ended up ejecting approximately 1,000 metric tons. Quick Google search reveals that this is somewhat equivalent to a typical cargo ship, with recent calculations also discovering that the total amount of impact resulted in a change of momentum approximately 3.6 times greater than the expected value. Or in other words, by producing this ejecta, it added approximately 240% of total momentum to deflect the body, with all of this extra momentum coming from the ejecta itself, to some extent acting like a rocket engine. Which of course suggests that if the asteroid was made from something else, for example if it was more solid, or maybe made out of some kind of a volatile material, or potentially made from even smaller grains, this would result in a completely different amount of redirection. For a hard rock, for a hard surface, it would very likely be much less, basically similar to the expected value, with the orbital change being about 70 seconds. And so this insane amount of ejecta that was generated as a result of the collision turned this asteroid into a kind of a less efficient rocket just for a little bit, with the resulting crater that was generated by the collision sort of acting like a rocket nozzle, with all of this contributing the majority of the effect. In other words, most of the redirection really happened because of the ejecta, not because of the collision. And that's pretty much exactly what the scientists were able to kind of identify in the study that you can find in the description. In this case, this was a really intriguing study, because it involved a miniaturized version of all of this right here on planet Earth. And so here they actually constructed a kind of a replica of a chondrite asteroid, and then collided an object moving at approximately 5 km per second with the asteroid replica, in the process discovering how a lot of the debris here creates extra momentum by essentially redistributing some of the mass and expelling it in a certain direction, with pretty much nothing left at the end. Here's actually what the resulting debris sort of looked like following this collision. But what's intriguing about this study is that their model was able to predict that the resulting collision would create approximately 3.4 times more momentum because of the resulting ejecta. And since the observations revealed that it was about 3.6 times higher, the actual prediction is extremely close. It's probably a little bit off because in this case this object was moving a little bit slower. And having someone's theory pretty much agree with the actual observations provides an almost definitive explanation for what happened here. And more importantly, provides more evidence that this is an extremely efficient technique at redirecting various types of asteroids, even by using smaller objects. In case you're wondering how they were able to shoot something so fast at this particular object, they used this right here, a large 2-stage light gas gun facility that literally resembles a massive gun that can shoot out things at several kilometers per second. You can learn more about this in one of the files in the description below. And so the results from the observations and the experiment definitively suggest that if you have something that's moving really fast and then collides with the typical asteroid, it will result in the asteroid briefly turning into a miniature rocket, with the collision speed and also the composition of the asteroid very likely playing the most important role, but also probably the shape of the craft itself, with the overall cross-section most likely playing a role as well. Depending on the final shape of the crater that it generates, it will produce different amounts of total propulsion. But more intriguingly, even though the initial change in velocity and the orbit was relatively small, over time this will add up to a dramatic change in orbit as these rocks orbit around one another. And so even now, continuous observations of these two asteroids are really important in figuring out what effects this has long term. Here's actually one of the ways the scientists usually measure the orbit of the smaller asteroid around a larger one. They essentially look at these changes in brightness over time. And so one of the suggestions from some of the recent studies is actually in regards to the change of shape and also possibly change of the rotation speed of one or even both of these asteroids. it's actually quite likely that the resulting collision will have actually changed the distribution of mass around the smaller asteroid, and as a result will affect the larger asteroid as well, especially as some of the debris might actually come back and fall back on the surface of both asteroids. And this change of mass distribution might also overall change the shape of both, or at least one of the asteroids. In this case, reshaping either body is actually going to change their mutual gravitational field, which over time will dramatically change their orbit around the Sun as well. Now this will take many years, but this is why it's going to be important to do a follow-up in order to see what actually happens here in 5, 10, or even 20 years. Now European Space Agency is developing Hera, a spacecraft that's going to be doing a kind of a follow-up in 2026, but this is of course just the first step. Because the larger asteroid, Didymos, is actually rotating really fast, almost at the brake velocity. Basically, if it was spinning a little bit faster, it would kind of fall apart. The reshaping-induced orbital changes could in theory send this asteroid pair in a somewhat different orbit within the next few decades. Now, it's not going to be more dangerous in any way, but because this is an important experiment, it's also important to understand all sorts of long-term effects this might have on various types of asteroids, depending on various properties. Nevertheless, the mission has so far been a tremendous success, and definitely provides us with at least one method we can use to potentially redirect a dangerous asteroid that might one day hypothetically collide with planet Earth. In 1967, a young researcher named Jocelyn Bell identified an unusual radio emission that you can kind of see right here that was very predictable, seemed to have a pattern that we've never seen before, and more importantly, was coming from the same location in outer space. This signal back then did not have a name, but almost right away, researchers started referring to it as LGM, Little Green Man, because this was, at that point, the best evidence we had for potential alien life. But it didn't take long for the scientists to figure out that it actually matched better with another theoretical prediction from astrophysics. These unusual signals, which were then detected elsewhere, were better explained by another concept known as the neutron star, with powerful enough magnetosphere to produce very powerful emissions in two directions, with this new concept eventually being referred to as a pulsar, or a pulsating neutron star. And this was essentially a discovery of a completely new object that would eventually redefine how we see astronomy, but also in the process teach us so much more about the universe that we never knew before. Hello wonderful person, this is Anton, and so today we're going to be talking about that big announcement of 2023. One of the biggest international collaborations in terms of scientific research that finally physically confirmed something we've been suspecting for a pretty long time. Our universe seems to be filled with a lot of different vibrations coming from the space-time itself, so-called gravitational wave background. In essence, background noise, where the space-time itself starts to oscillate, vibrate, move around, shift around, without pretty much anyone noticing anything, and only visible if you study distant objects with very precise observations such as the ones that pulsars allow us to do. And so in this video, let's go through some of these discoveries and what we know so far and what future research will probably reveal. Now technically this video is part 2 and the previous video is in the description below and goes through a lot of clarifications on previous research and previous data discovered in the last few years. But because I know most of you will probably not watch that video and instead want the answer now, let me give you the basic summary. So in general, the gravitational wave research is a relatively new field. I mean, it existed for a pretty long time since Einstein proposed it over 100 years ago, but the actual proof of gravitational waves only came in 2015. And since 2015, various facilities have already uncovered approximately 100 different gravitational wave events, with some being really intriguing and somewhat unusual. You can find some of them in the description below. But so far all of these events involved either a neutron star or a black hole colliding, producing a very specific frequency. Usually a frequency in hundreds or thousands of hertz. Technically something that should be audible to human ear, but because we're talking about gravitational waves, which basically oscillate the space-time itself and not any molecules or atoms, the only way you'll be able to hear this is actually if you were extremely close to the source of a collision. And so technically you could hear it, but you'd probably have a lot of other problems to deal with, such as being so close to a black hole. Anyway, more about this in one of the future videos that should be on the channel really soon. So make sure to subscribe if you want to learn more. But in terms of the gravitational wave spectrum, just like with other frequencies, it is a really large spectrum. You can obviously have things that are extremely high in frequency, such as for example coming from rotating neutron stars or supernova, or you can also have things that are extremely low in frequency. And here we're talking about objects that are much more massive and possibly produce waves that are much higher in amplitude. So I guess one way of imagining all of these waves together is sort of imagining an ocean. We have all of these waves bouncing around, all sorts of waves interacting with one another, some waves larger than other waves, and some waves barely perceivable by anything. And so some of these larger waves, or waves that have a very long wavelength, would practically be undetectable from planet Earth because they would pass through Earth without anything ever noticing. And I think here one of the best analogies is, once again, ocean waves, but in this case, tsunami waves. Now today we actually have a really intriguing technique in detecting incoming tsunami waves before they can cause damage on land. Normally when a tsunami is in deep ocean, it's almost impossible to feel it or detect it unless you have specialized buoys with specific sensors. And here it's because the wavelength of these waves is extremely long. For a wave in a deep ocean, the wavelength can be in hundreds of kilometers and only have an altitude of approximately a few meters, maybe even lower. But by using surface buoys anchored to a certain location, it's possible to detect minute changes when tsunami wave passes through them. And so by having several of these buoys around the ocean, it then becomes more obvious that something is actually coming toward land, thus producing what's known as a tsunami warning. And these are usually almost 100% accurate. But if it wasn't for these buoys across various locations in the ocean, it would be impossible to detect these waves. In a nutshell, that's sort of what the scientists did here as well. Except that the buoys in this case are very distant pulsars. Pulsars located hundreds or even thousands of light years away from one another and in different locations across the Milky Way. But pulsars whose pulsations have been measured for many years and whose pulsations are extremely precise. We're talking about atomic clock precise. I mean, it's actually been suggested that we use these pulsars to measure time instead of atomic clocks. That's how precise they are. But sometimes something happens, and the actual pulsation gets a bit of a glitch. Now, this does happen inside neutron stars, very often because of some kind of a reshuffling, or essentially some kind of a, for the lack of better words, starquake. But what if this unusual glitch happens around several pulsars, and especially if those pulsars are hundreds or thousands of light years apart? Now that becomes a little bit more intriguing. Why would several pulsars suddenly experience a similar glitch even though they're so far apart from one another? The only reasonable explanation that makes sense is that it's actually the space-time itself that glitched. In other words, it's possible that some kind of a space-time tsunami passed through this region and glitched all of them at the same time. Now this is what we would call a nanohertz gravitational wave, or a gravitational wave whose amplitude is in hundreds or thousands of light years in length, which we believe can be produced by very, very massive objects, such as for example supermassive black holes or even interaction between galactic objects. But I guess more importantly, it's something that could be going on around us at all times, because some of these black holes are going to be orbiting around one another for a very, very long time. And as they orbit, they produce these waves. But there are many of them, so they actually produce a kind of a massive gravitational noise. A vibration with wavelengths in hundreds and thousands of light years that seems to be detectable only if you look at these distant buoys, pulsars. And well, that's precisely what the scientists just did. Actually, they didn't just do it. They've been doing these observations for the past 15 years, and this is their third official release, with this one being particularly exciting because it seems to suggest that there's definitely something out there, but something that we currently cannot explain. Now I'm going to try to post all of the studies behind this in the description below, and there are quite a few studies by the way, but so far every one of them discovers the same thing, and to me personally this is the best part of this research. This was several independent teams from different countries, from different facilities, and even using completely different pulsar data that all did pretty much the same research and found pretty much the same thing. They all discovered undeniable proof that there is a background gravitational noise that actually even seems to be a little bit louder than anyone expected. And it could not have come from pulsars themselves, it could not have come from, for example, errors in measurements. It really seems to be a result of something super massive, creating large amounts of waves all across the universe, vibrating the entire galaxy and essentially creating this unusual background noise. Noise that makes everything sort of wobble and move around, but in a way that's not really perceivable to physical life. I mean, the only way we can actually see this is because we're observing these precise observations from individual pulsars, but without these pulsars, it would be impossible to see this otherwise. But because we're seeing these glitches coming from pulsars in a very specific way, it implies that something is definitely happening there. And in total, all of these teams together studied 115 different pulsars, but they actually chose different pulsars based on the observations and the data available. And to be more specific, the biggest team was from Nanograph, North American collaboration. We had the same results but using different pulsars from EPTA, which stands for European Pulsar Timing Array. Same results but different pulsars from the Australian Parkes Pulsar Timing Array, PPTA, that's actually been collecting data for over 20 years now. Same results, different pulsars from CPTA, Chinese Pulsar Timing Array, this one using the largest radio telescope we have on the planet, the Chinese FAST telescope. Same story, same results from INPTA, Indian Pulsar Timing Array, and SAPTA, South African Pulsar Timing Array as well. And all in all, this is one of the biggest scientific collaborations since the results from the EHT or Event Horizon telescope that became famous for releasing the first picture of a black hole. And so here the results are very difficult to argue with. Different teams, different pulsars, exactly the same results. And the result being that there is a long wavelength gravitational wave producing some kind of a low-pitch hum. Although what exactly is producing this hum is a question that nobody can answer right now. It could be obviously black holes, with binary supermassive black holes being one of the best candidates, but it could also be a lot of other things as well. For example, one of the suggestions here is maybe this is from various cosmic strings, the result of a rapid change in the early universe that produced these unusual formations that created vibrations in the early universe still audible today. If so, this would be a direct result of the concept known as inflation, or the sudden increase in size of the entire universe. Likewise, another proposition involves the idea of the Big Bounce, the precursor universe that might have collapsed on itself before starting a new Big Bang. So maybe here we're hearing remnants of the previous universe. Now that's a very big assumption and it's definitely going to require way more evidence, but it is currently one of the alternative explanations. Likewise, maybe this is something to do with pulsars themselves. Maybe we've discovered a completely new property of pulsars we've never known about before, and it's nothing to do with waves at all. It's the pulsars that are doing this unusual vibration. But still, the most likely and the most accepted explanation is in regards to supermassive black holes, very likely orbiting around one another in centers of various galaxies across the universe. In this case, we're talking about thousands or maybe even millions of them, with many of them potentially on a collision course as well. But in this case, this does create a bit of a problem because physically, or in terms of observations, we haven't really discovered that many of these supermassive black hole binaries compared to what the scientists predict so far. There's even something called final parsec problem that you can learn more about in a video in the description that sort of suggests that it would be very difficult for supermassive black holes to collide, but more importantly, so far, there's actually only a handful of potential candidates for galaxies with maybe binary supermassive black holes in the middle. And so the fact that they're not very common is one of the mysteries of modern universe. Nevertheless, the discovery from these pulsars that you can see right there across the Milky Way is almost definitely there. It's almost 5 sigma, and in physics 5 sigma is very difficult to argue against. Okay, technically it's actually 4.6 sigma, so here the percentage is something like 99.349% correct. But because there are several teams doing the study and they all have the same result, it's actually very likely to be true. But I guess more surprisingly, the evidence here suggests that the waves themselves are also at least twice as loud as they were expected to be. So the universe is not just vibrating, it's also vibrating kind of loudly, producing these wavelengths thousands of light years in length, coming from some mysterious objects out there. But this is of course just the first discovery, with this research still going on actively for at least a few more years. Now we might have more confirmations within the next year or two, but the actual observations are going to be done for at least 4 more years, possibly longer. And following this, within the next couple of years, we might finally see some of the hotspots where these gravitational waves are coming from individually. At the moment it's all just noise to us, we don't really know what's happening, but eventually we'll hopefully see the source. And since the noise was discovered to be so loud, it has to be something really massive. More massive than anyone expected. And so naturally we're going to be coming back and talking more about this in some of the videos in the future. So here's a topic that's always fun to talk about. Planetary collisions. Two planets go boom. A really fascinating topic for a lot of different reasons, including the fact that this is how we believe the Earth and the Moon were created as well. Two similar planets on the same orbit collided approximately 4.5 billion years ago, forming a relatively large disk that eventually turned into modern Earth and its partner, the Moon. And though the story of Earth and Theia is quite well known and quite well understood, with a lot of evidence behind it, discovering similar events in a lot of other star systems can actually one day help us understand why Earth is so different compared to everything else. And so discovering yet another one of these planetary booms somewhere out there is of course really exciting. But what makes this one exciting is just the sheer scale. It was so extremely powerful and so extremely destructive that even the star system itself and the star itself dimmed by 95%. So yeah, hello wonderful person, this is Anton, and let's talk about this event that was recently discussed in one of the papers that as always you can find in the description below. A planetary collision afterglow and transit of the resultant debris cloud. An event that was originally reported by the automated system known as the All-Sky Automated Survey for Supernova, ASSASSIN, that, as the name implies, looks for sudden changes in luminosity around various stars, because usually it means that something is happening here, such as, for example, a sudden supernova. And back in 2021, one of these events was reported for a slightly different reason. Instead of increasing in luminosity, this star rapidly faded, with this somewhat typical Sun-like star dimming by as much as 95% extremely quickly, with further examinations determining that it wasn't just the optical dimming, because 2.5 years prior there was also a dramatic change in the infrared emissions that actually did the opposite. It was an increase in infrared brightness. And though all of this was at a relatively faraway distance of approximately 1800 light years away from us, a lot of modern telescopes were able to distinguish everything here and were actually able to answer some questions. And well, first of all, this is apparently a relatively young Sun-like star, possibly around 300 million years old. So not a baby star anymore, but definitely still young. It was also obviously experiencing something very dramatic that was happening extremely fast, but was not changing the star permanently. Basically, this unusual dip was only temporary. But the changes here were different depending on the type of the light that was being received from the star. And so yeah, optically, the star became extremely dim. Even much dimmer than the famous Tabby star, where a few years back scientists proposed that, maybe just maybe, this was actually a result of some kind of alien technology. Basically an enormous Dyson sphere or Dyson ring. We know that this is not the case anymore, because there were definite signs of different types of dust. But because here the dimming was much higher, it was a much more interesting star. And that's until you actually look at the infrared spectrum as well. Here it became very obvious that there was a dramatic brightening consistent with a temperature of about 1000 Kelvin, with actually very similar properties to what we often find around various protoplanetary disks. Young stars with very hot disks around them. And so because the stars seem to have doubled in brightness approximately 3 years before dimming so much, the overall conclusion here was some kind of a collision, because these effects are expected when two objects collide. You can actually find at least one video in the description that talks a little bit more about previous detections, but in essence, in the last few years, there have been quite a few huge dust formations from various impacts detected around various stars. For example, just a year ago, HD 166191 had very similar changes in luminosity and the overall increase in infrared light, suggesting a release of a lot of hot gas all at once. In this case, it was believed to be a collision between two planetesimals, much smaller planetary bodies. Likewise, quite a lot of collisions have been detected in the V488 Persei disk, in essence showing us what happens when these planetesimal collisions happen over and over again. This is a young disk where this happens quite a lot. And so in all of these cases, there was basically a change in infrared brightness and usually a slight dimming of the star. And that's because when two objects collide, the first thing that they do is essentially explode, producing a lot of hot gas, but right after this, all of this gas sort of starts forming a relatively large donut-like shape around the star, in some sense very similar to a typical ring. And this ring, depending on the position and depending on the angle, can basically cover the starlight, making the star appear much dimmer. And so just to illustrate this, a large enough collision is basically going to produce a huge cloud of dust that's then going to form a kind of a ring-like shape, eventually covering most of the star in the process. And the two effects we expect here are obviously infrared brightening and optical dimming, which is precisely what was first observed 3 years ago, with the visible light then dropping dramatically when all of this dust covered the star. And so essentially so far all of the observations from the star seem to suggest a really large planetary collision. But the analysis from this paper revealed that the collision itself was absolutely massive. Not just two planetesimals like before, not just two comets, or smaller bodies producing just a little bit of dust. Here we're talking about two huge planets, potentially similar to Neptune, smacking into one another at relatively high velocities, literally destroying each other, and even producing a bright enough flash and a huge amount of energy as the star produces in 2 years. And so because of this very bright explosion, that's why this was detected by the automated Supernova survey and why it became so mysterious and so unusual. And by working out the exact details, the researchers behind the study believe they understand exactly what happened here. Two Neptune-like planets somehow ended up on the same orbit, which resulted in a massive explosion when they collided. Why exactly they collided is unclear, but something must have changed their orbit enough in order to have them cross at some point. And the amount of energy released in this case resembled a tiny nova-like explosion visible to various telescopes. Then for the next 2.5 years, we didn't really see much, except for if you looked at this in the infrared. The entire system started to light up dramatically, with the torus-shaped ring eventually orbiting the star system and producing the heat around it. But right in the center of the ring, there was also a really hot remnant that was very likely even hotter than the star itself. But intriguingly, the torus shape that was produced was not as hot as expected from terrestrial planets. It should have been at least 1400 Kelvin, but the temperature was much lower. Because of this, it's actually believed that this was not terrestrial planets, but most likely gas giants, and very likely Neptune-like worlds. With the collision being so massive and so powerful that when they actually exploded, they produced this really hot ball of silica that was very likely at least 7 times as big as our Sun. Basically this huge glowing molten shape that existed here for just a few months, but eventually started to spread out and formed a ring shape around the star. And then, at some point later, essentially in 2021, we got to see the unusual dimming from the star when all this passed in front of the star, blocking the light by about 95%. And because all of this took approximately 3 years to complete, scientists believe that the orbit of these planets was probably very similar to Jupiter in the solar system. And so in this case, approximately 20 to maybe 40 masses of planet Earth got completely vaporized, forming a huge plasma-like structure, with a tiny part of it then forming into a central hot object in the middle. And it's this object that's now going to form a new planet, potentially even with many different moons, in an extremely similar way to how Earth and the Moon formed from the collision 4.5 billion years ago. Although in this case, this will probably take at least a few thousand years. It's quite unlikely we're going to be seeing any moons or any specific formations here for quite some time. Either way though, this star system presents a really good opportunity to study exactly what happens when two planets collide and also try to connect all of this to the formation of planet Earth and the Moon. And so at least for now, the plan is to keep watching the star system just to see how things change. If the assumption and the explanation here is correct, it's expected that the debris field in this case is going to start spreading out into a wider orbit, creating a more diffuse formation, something that should be visible to future observations because it will still occasionally block the starlight when some of it passes in front of the star. And so we'll definitely be coming back and talking more about this in some of the future videos. But I guess just the fact that scientists were able to detect this, and it was such a dramatic, huge explosion, in some sense suggests that planetary collisions might be not as rare as we initially thought. These events might actually happen in a lot of different star systems, and may end up having very similar effects on the star system and even produce somewhat similar planets. And in order to understand how planet Earth was formed and why it's the way it is, we definitely have to understand the formation history starting with the collision itself. And so this is a pretty exciting discovery for a lot of different reasons. Hello wonderful person, this is Anton, and today we're going to be discussing some other really exciting discoveries coming from the Milky Way galaxy, and actually discoveries that once again, nobody kind of expected. Discoveries that you can learn more about in one of the papers in the description below. But also a discovery that's, in some sense, almost like 45 years in the making, because the scientist behind this main paper has been studying these particular phenomena since the early 1980s. And it's essentially directly related to that discovery from the 80s of these unusual floating filaments discovered around the galactic center. If you want to take a trip back in time, here's that original paper by the same scientist published 39 years ago. And so back then, he discovered these unusual filamental formations that were basically only visible in radio light. And quick reminder, if you actually want to ever see what the galaxy looks like in the radio light, check out the map in the description that allows you to see everything in the X-rays, in the gamma rays, in the infrared light, microwave light, and lastly, radio light. And so when looking at the Milky Way in the radio light, something exceptional comes into view pretty quickly. Our galaxy contains a lot of these very beautiful filamental features, very often up to 150 light years in length, vertical in orientation, and most likely following the magnetic lines of the galaxy itself. And the scientists behind this paper discovered over 1,000 of these in the last 4 decades. As a matter of fact, we've discussed many of these discoveries in the past because they do show our galaxy in a very different light, and serve as evidence for magnetic interactions within the galaxy and powerful magnetic lines that most likely influence various star formation and also guide a lot of gas around the galaxy. But these previous discoveries were usually magnetic in nature and almost always vertical, and also mostly served as a direct proof of other observations from similar galaxies, especially with the famous Sophia telescope, that directly show us various magnetic fields and magnetic lines visible in many of these galaxies as well. And a lot of these formations always have these filaments and these beautiful line-like formations that seem to follow magnetic structures in each of these galaxies. So basically this was a kind of an indirect proof of the existence of powerful magnetic fields within each of these galaxies, including the Milky Way. It was never really doubted, but this was a direct proof. But this time, the same scientists, using very similar techniques, but obviously using new improved telescopes, discovered something that even they did not expect. Mystery filaments align in a very different way, almost always along the galactic plane as opposed to vertical to it. And interestingly enough, almost always pointing toward the center, which was very different from previous observations from previous filaments. And here's actually what all of this looks like if you were to combine both. And more intriguingly, implying that there seem to be at least 2 different populations of these filamental strings, and possibly with 2 different origins, with this new discovery almost certainly connected to the central black hole Sagittarius A star. Because unlike other filaments, it seems that these ones are aligned in a way that they kind of point in the direction of the central black hole. And though they're also magnetized and are only visible in radio light, they are different in properties as well. So for example, these previous filaments that do seem to be kind of random and don't really have any connection with one another are definitely different from these ones, which all seem to be tied to the center of the galaxy. And even the scientists behind this paper were actually surprised to find them because they expected all of them to be vertical, following the magnetic lines. But unlike these vertical filaments, these new structures are pretty much just short lines. Most of them are only about 5 to 10 light years in length, but there are like hundreds of them, all pointing in the same direction. And although all of them are magnetic in nature, the long structures, the vertical ones, can usually easily accelerate particles to near the speed of light, but these tiny horizontal structures do not. Instead, they seem to emit thermal energy. And more importantly, they're not equally distributed across the galaxy. For some reason, a lot of these newly discovered filaments are mostly arranged on one of the sides of the galactic center, almost as if they're pointing at the radial outflow from the previously active astrophysical jets. The jets that we believe must have been active a few million years ago based on various observations, but that are no longer active now. And more importantly, if you actually trace back when these particular emissions must have started, it seems to have happened approximately 6 million years ago. Which in essence implies that approximately 6 million years ago, something must have formed all of these powerful emissions that eventually produced all of these tiny magnetic lines coming from the center of the galaxy. Which of course implies that our galaxy was probably very active 6 million years ago, emitting very powerful emissions in the process, producing powerful accretion disks and a lot of other electromagnetic effects, and also producing powerful jets that then left behind these unusual filaments. And if this assumption is correct, it actually means that we can now potentially study the accretion disk of the ancient Sagittarius A star. By studying each of these filaments, it might become possible to work out the black hole spin, the size and the power of the accretion disk 6 million years ago, obviously the orientation of the black hole and the accretion disk, and possibly even what exactly caused all of this. And then maybe even work out if this had any effects on planet Earth. It would also be quite important to find the connection between this and the famous Fermi bubbles, although in this case, the Fermi bubbles are believed to have been formed possibly about 2 to 3 million years ago, so there's definitely a bit of a time difference. And though these events might be connected, there's also a possibility that maybe these were two separate events, suggesting that our black hole does this every few million years or so. It basically becomes active, starts spewing out a lot of matter from every direction, creates powerful accretion disks, powerful jets, and leaves behind powerful radiofilaments visible from very far away. At least that's one of the first assumptions. The other assumption could be maybe a little bit different. It's also related to a recent study on the so-called Rosetta bubbles, very similar bubbles but only visible in the X-rays that are much bigger, much more powerful, and seem to have been a result of a major star formation in the galactic center and not the activity from the black hole. And so for all we know, maybe these bubbles produced various powerful emissions because of various supernova all happening at once, which then, as they spread away from the center of the galaxy, produced these radiofilaments now visible as the formations that the scientists recently discovered. In other words, the actual origin of this is still not really clear. It was definitely a result of something very powerful and something involving a lot of magnetic interaction, but whether it was star formation, black hole emissions, or something entirely different we don't understand just yet, is a question we cannot answer yet either. But it's definitely something we might be able to answer because of all of these new observations and all of these very powerful telescopes, such as the Meerkat radio telescope that discovered these new formations, that in the next years might help us answer more of these questions about what exactly happened in the Milky Way a few million years ago, and I guess more importantly, if it had any effect on planet Earth. The answer to this for now is most likely no, but that's kind of the question I would like to be answered at some point in the future. And once there is some kind of an answer, I'll make sure to follow this up with another video. Today we're going to discuss a relatively unusual discovery of an extremely long and extremely straight stellar stream. A formation that usually resembles something like this in a typical galaxy, even though normally we imagine galaxies to be like this, and a formation that was discovered completely by accident 300 million light years away from us inside the Coma cluster. But in this case, it's extremely long, 1.7 million light years across, extremely straight, and we've never seen anything like this before. And so, hello wonderful person, this is Anton. Today we're going to discuss this new discovery, briefly talk about other stellar streams and how they form and why they're important, but also discuss some mysteries in regards to this unusual object as well. But let's start with the basics. So even though we imagine galaxies to be like this, pretty much most galaxies out there, especially the ones that are more massive and experience a lot of collisions, will actually resemble something like this. They'll essentially contain a lot of features around the galaxy, with many barely visible, but some staying around the galaxy for a very long time. And in most cases, this essentially represents the evolution of the galaxy as it grows larger. These are remnants from various galactic collisions. In essence, as galaxies collide and as they evolve over time, they will usually produce these very long stream-like formations that kind of look like little scarves that stay in the region for billions of years. And here you're actually seeing an example from the Andromeda galaxy. This was discovered a couple of decades ago, confirming the overall ideas we have about galactic evolution, galactic collisions, and how galaxies form. More importantly, a lot of them have been discovered around the Milky Way. For example, the famous Helmi stream, also became famous because approximately 10 years ago, scientists also discovered an exoplanet here. A planet that was around a star that was about 8 billion years old, suggesting that this was the first discovery of a planet from a different galaxy. Helmy stream very likely formed in a very similar way from a different galaxy that fell apart, and so inside of this galaxy there was a star with a planet that's now been discovered inside the Helmy stream. And then there was this absolutely gorgeous image of this galaxy known as NGC 5907, taken by J. Gabany from Blackbird Observatory, with these beautiful loops extending approximately 150,000 light-years wrapping around the galaxy. Obviously confirming that this is something universal, seems to exist everywhere, with most galaxies potentially having these beautiful scarves. Scarves formed by tidal forces from the main galaxy as it shreds apart its partner. But inside the Milky Way galaxy, so many more have been discovered over the years. And mostly in the last few years because these structures are still kind of difficult to see, simply because they're relatively diffuse and often do not contain a lot of stars. And so a lot of these smaller streams are pretty much everywhere around the Milky Way, with many connected to various globular clusters, basically suggesting that the Milky Way ate quite a lot of galaxies in its past, eventually becoming the galaxy we know today through literally galactic cannibalism. But quite a lot of these streams are relatively short and very likely came from much smaller dwarf galaxies. There are, however, two streams around the Milky Way that are surprisingly giant. The first one is much closer to the center of the galaxy, but also contains long tails much farther away. It's known as Sagittarius stream. It's a very long, very complex structure that's approximately 1 million light-years in length, consisting of a lot of tidally stripped stars that actually seem to even go through the galaxy, crossing the galactic pole and the galactic disk in several regions. And this is most likely the leftovers from Sagittarius dwarf elliptical galaxy, a result of the merger between this galaxy and the Milky Way. Something that seems to have taken billions of years because originally this galaxy potentially was one of the most massive absorbed by our own galaxy. And this cluster, known as Massey 54, potentially formed its center in the past. This is basically its galactic core that escaped over time. Interestingly, as this galaxy interacted with the Milky Way, it disturbed a lot of gas inside the galaxy and very likely led to massive star formation in a lot of parts of the Milky Way. At least a few studies have even linked this to potentially formation of the Sun. So, to some extent, our solar system and planet Earth potentially exist because of this galaxy and its influential interaction with the Milky Way. But these types of streams are relatively easy to explain. They've also been simulated in various supercomputer simulations, so generally astronomers understand them pretty well. However, this looks nothing like them. It's straight and it's super long, 1.7 million light-years in length. That's almost double the length of the one I just showed you previously, Sagittarius stream. And so we don't really know exactly what's happening here, but there might be some clues from another stream very close to us. And so unlike galactic collisions, there's maybe another way to produce these streams that form slightly different shapes. And the stream we're talking about is known as the Magellanic stream. Literally the longest stream close to us that seems to cover approximately 100 degrees of night skies if you were to look at it from planet Earth. And as the name implies, it has something to do with Magellanic Clouds, the two dwarf galaxies orbiting the Milky Way. Today it's believed that it's a result of some kind of a tidal interaction between Magellanic Clouds and the Milky Way that started removing gas and stars from these galaxies, creating a long, relatively straight tail. And this unusual structure is exciting for so many reasons. For example, not so long ago, astronomers finally found actual stars in here. They also found star clusters, or constellations of stars. But more excitingly, relatively recently, they discovered what's known as a light echo. You can learn more about this concept in one of the videos in the description, but in a nutshell, it's an echo produced by the gas inside the Magellanic stream that's reflecting extremely powerful activity from the outburst of the central black hole inside the Milky Way. And so approximately 200,000 years ago, the central black hole in the Milky Way very likely emitted a lot of light and produced very powerful emissions, a result of some kind of an outburst, most likely because it became active for some time. And all of this light, this very powerful light, started to travel in various directions and at some point crossed one of these streams. And we're now basically seeing the reflections from it, allowing us to both study the central black hole, but also the Magellanic stream itself. And the only reason we can see it is because the stream is humongous, and it also seems to be relatively flat. although computer simulations and previous studies established that it might look something like this, L-shaped. Now that's definitely unusual, but notice how both parts are relatively straight, relatively flat, and do not wrap around the galaxy in any way. And so the answer to that new discovery could be somewhere right here. This object, that's about twice the length, 1.7 million light-years across, and the first such formation seen anywhere, is very likely a result of extremely dynamic interaction inside the Coma cluster, possibly produced by one of thousands of galaxies located in the region. And so if this was formed by just 3 galaxies, this most likely was formed by interaction with hundreds if not thousands of galaxies. And it most likely formed in a very similar way. Some kind of a dwarf galaxy was completely pulled apart by gravity from much bigger partners, stretching it longer and longer in the process, creating a very long, very thin formation. And a formation that seems to be mostly in orbit around a much larger galactic cluster you see right here. Which is actually how all of this was discovered. Originally, the scientists behind the paper in a description were using the Jean Rich telescope along with the William Herschel telescope to try to look at various faint structures in the Coma cluster in order to study the galactic halos and to learn a little bit more about the mysterious dark matter. And while studying these halos, they discovered this unusual filament that didn't seem to fit in. It didn't look like any kind of a cosmic web or a galactic filament that's usually visible in radio light. Instead, this was some kind of a high-velocity cloud with a lot of stars that was orbiting the central region. And so because there are thousands of galaxies in the middle here, they very likely did something similar to what you see here, but just on a much larger scale, completely stripping the dwarf galaxy of everything and leaving nothing behind except for just a long, thin line of gas, stars, potentially dark matter, and possibly the central black hole somewhere in the middle. So basically this galaxy became kind of spaghettified, I guess. But right now this is all the scientists see. They don't actually see the galactic core, they don't see anything else here, and the stream itself appears to be kind of featureless. So there are still some unanswered questions. But this is a very important discovery for scientists studying galactic evolution and trying to solve mysteries of things like dark matter, because that's precisely what they were trying to discover here, it's just they found something they didn't expect. And so in some of the future studies, we might actually finally see how all of this formed, which by the way you can actually even see in this simulation from the Illustris project, with future discoveries possibly even finding something longer, bigger, and more impressive. Right now though, as of 2023, 1.7 million light-years across seems to be the record. Hello wonderful person, this is Anton, and today we're going to be discussing a discovery of a very strange object. Basically, the hottest object that's not a star. An object whose temperature is so extreme that it's literally hotter than our own sun. But an object that's not a star at all, and it's actually kind of closer to being a planet. And so in this case, let's discuss a little bit more about what exactly the scientists have recently discovered, and talk about how this object was formed, and what exactly this means for astronomy in general. But first, so what exactly is this and where is it located? It's approximately 1400 light-years away from planet Earth, and it's actually a somewhat typical binary system. A system containing 2 objects orbiting around one another. But unlike a typical binary system with 2 stars dancing around a central point, here the central star is a white dwarf. The end result of stars like our Sun, that after billions of years of existence expel their outer shell, leaving behind nothing but the star's core. And that core is the white dwarf that occasionally has different objects in its orbit. And in this case, this object does seem to have something in its orbit, something that's almost a star in terms of mass. An object with a mass of 75 to possibly 88 masses of Jupiter, but also an object that orbits very close to the white dwarf. Now normally this would qualify as a brown dwarf, but at these masses it's actually right at the limit where it should technically become a red dwarf or basically a star. Yet it doesn't seem to be one, but it's really the other properties, specifically temperature, that seem to make no sense. Although here, let's briefly talk about the, previous record holder. So, a few years ago, by studying various exoplanets out there, and by looking at their passage in front of various stars, the scientists identified an extreme star system known as Kelt 9. Here the planet, Kelt 9b, was orbiting so close to the star that it basically became the hottest planet ever discovered. The planet, whose temperature on the surface was over 4000 degrees Celsius or approximately 4600 Kelvin. But all of this was a result of a close orbit to the star and the star itself being relatively hot as well. But for nearly 8 years now, this was the record holder, and it definitely taught the scientists so much about these extreme objects. For example, because of these extreme temperatures, quite a lot of material here basically dissociates, turning into atomic elements, with a lot of these chemical elements eventually going through so many different changes that we didn't know existed until observations from a few years ago. You can find one of the older videos somewhere in the description that goes through these recent discoveries. But with a temperature of 4600 Kelvin, the scientists for many years believed that this is maybe as hot as it gets when it comes to extreme planets and extreme atmospheres. Anything hotter than that would be almost impossible. But not everyone believed so, and some scientists assumed that we can maybe find something even hotter around objects that are a little bit more extreme and a little bit more unusual. Specifically, very young white dwarfs with extreme temperatures on their surface. Now, a typical white dwarf actually starts really hot after it becomes a white dwarf. Here we're talking about tens of thousands of degrees Kelvin. And over time they do lose quite a lot of this temperature because there's basically nothing providing any more energy within them. But that cooling process takes billions of years, and it will actually take trillions of years for these objects to cool down enough to barely produce any light. And so in order to study even more extreme environments, the scientists behind the study wanted to find something similar around a typical white dwarf. They basically wanted to find various gas giants, or maybe even brown dwarfs, inside some kind of a white dwarf system. And because white dwarfs are also much smaller than typical blue supergiants, it would be much easier to see any companion, especially the one that's heated, orbiting around these objects. And the point here was to find some kind of a brown dwarf, or some kind of a Jupiter-like object, that would be close enough to the white dwarf to be dramatically heated by its emissions. Although normally, when we talk about brown dwarfs, we basically refer to objects that are at least 13 masses of Jupiter. Objects that acquire just enough mass to no longer be planets and to start possessing new properties, including certain types of fusion inside their core, but not hydrogen fusion, so basically they're not stars yet. They do fuse deuterium and sometimes lithium, so they can actually produce their own heat and thus increase in temperature with mass. Although some of the most extreme brown dwarfs discovered so far have actually never been above 18 Jupiter masses. At 80 Jupiter masses, the average temperature on the surface would be about 2500 Kelvin. So not as hot as a typical red dwarf, but much hotter than anything else. One of the videos in the description talks about some of the more unusual discoveries in regards to brown dwarfs in the last few years. But what happens if you put a very hot brown dwarf next to an extremely hot white dwarf? And that was basically the question the scientists behind this study were trying to answer. And turns out that what happens is an irradiated Jupiter analog hotter than the Sun. An object so extreme that its temperature is thousands of degrees hotter than most stars in the entire galaxy. And that's of course something that nobody expected. And so even though this particular white dwarf is not actually that extreme, it's only about 40% the solar mass, and its temperature is around 36,000 Kelvin, there are definitely hotter white dwarfs out there. Because of the proximity to the brown dwarf, with the orbit only taking about 2.5 hours, the residual heat coming from the white dwarf creates so much energy that it basically turns this unusual brown dwarf into something that's most likely blue or white in color, with the average temperature on the surface exceeding 8000 Kelvin, at least on the so-called day side. Because this object is most likely tidally locked to the white dwarf, it seems to always point with the same surface toward the white dwarf, and thus has one side that's much hotter than the other side. Just as a reminder, the temperature on the Sun is about 5700 Kelvin. And so here the temperature is so hot that most of the atmospheric molecules very likely don't just become atoms, they become ions and produce other unexpected effects that we've never really observed or even imagined happening anywhere out there. And so here, by observing this particular star system using European Southern Observatory's Very Large Telescope, and specifically the instrument specializing in ultraviolet radiation, the scientists were able to observe huge amounts of hydrogen that seemed to be coming off from the day side of this particular brown dwarf, but the temperatures observed here were anywhere from 7000 to even 9800 Kelvin. But even the night side here is relatively hot. Not as hot as the day side, but it seemed to be about 1300 to maybe 3000 Kelvin, or about 6000 Kelvin lower. And so here we had this very strange object that we've never seen before, whose temperature differed by about 6000 Kelvin one side to the other, with the day side being so extreme that it's actually brighter than a lot of A-type stars. But all of this was very likely the result of extreme heat coming from the white dwarf and because of the overall proximity. At these distances, any object would actually have temperatures of over 5000 Kelvin because of the emissions from this white dwarf, and specifically the ultraviolet emissions coming from its surface. It actually seems to receive thousands of times more ultraviolet radiation than the previous record holder, Celt 9b, which definitely makes this brown dwarf the strangest brown dwarf ever. It's obviously not even a brown dwarf anymore, and instead might represent a completely new object. Not only is its color no longer brown but more likely blue or even white, even its mass is way above what we expect from a typical brown dwarf, so it's not even clear what sort of fusion it has on the inside or if it technically can qualify as a red dwarf. But in this case, because it's so close to the white dwarf, it's also stretched quite a lot, and so in reality it's probably unlikely to have any kind of fusion because of various disturbances from its smaller but more massive partner. And so in this case, this is just a really extreme example of a somewhat strange, unexplainable object. I mean, we actually understand why it's so hot and what's happening here, we just don't really have a good name for it. But because the scientists now know exactly what to look for, chances are they might find something that's even more hot if they can find an even younger white dwarf with yet another brown dwarf orbiting very, very close. Although in this case, I guess the bigger question is, how exactly did the star system form? Or to be more exact, how exactly did this brown dwarf make it so close to the white dwarf, assuming current orbit? Since this used to be a much larger star, it should have actually swallowed or destroyed any object in the vicinity of its orbit. Moreover, it will be interesting to find out if the white dwarf is also stealing some of the mass from its partner and might one day produce what's known as a nova, a thermonuclear explosion which is usually a result of huge amounts of hydrogen and helium depositing on the surface of a white dwarf. It's not going to go supernova because it just doesn't have enough mass, but other types of explosion would be possible here. And if that does happen, it might even disrupt the brown dwarf, potentially creating something else in the process. But these are not the questions we can answer just yet because, once again, this is a relatively recent discovery, and this is the first time such an object was discovered anywhere. When it comes to finding unusual planets, there is quite a long list. Actually, there's an entire playlist of unusual exoplanets somewhere in the description. Some planets are weird for one reason. For example, there are planets that are too big, too small, too dense or not dense enough. Or, more recently, we've discovered a planet that was just a little bit too hot. As a matter of fact, hotter than the majority of stars in the entire Milky Way. But today we're going to be talking about another planet. An exoplanet known as 8 Ursa Minoris b that the researchers behind the study in the description have been basically describing as a planet that technically should not exist. A planet that somehow survived something that most planets do not. It somehow managed to survive the destruction by the star. Hello wonderful person, this is Anton, and so today we're going to be discussing this unusual planet, what the scientists believe might have happened here, and basically talk a little bit more about the mystery of a planet with the proper name, Hala. It's one of the planets that got lucky enough to receive a proper name. But in order to understand why this planet should not exist, we actually have to talk about the star first. The star that also has a proper name, and the name in this case is Bagdu. Bagdu and Hala, by the way, are the names of two biggest mountains in Korea. One of them is in North Korea, and one of them is in South Korea. And these names were proposed and accepted by the Korean researchers who originally discovered this exoplanet back in 2015. And so what exactly in the star system makes it kind of unusual? So first, the planet itself is not actually that special. It's about 1.3 masses of Jupiter, and it's also slightly bigger than Jupiter as well. It takes about 93 days to orbit around the star, with the orbital radius that's about half the distance of Earth to the Sun. It also has a relatively low eccentricity, or basically the orbit here is very circular, and overall the scientists refer to this kind of a planet as a warm Jupiter, a gas giant with a relatively hot upper atmosphere, but not hot enough to be considered a hot Jupiter. So definitely intriguing, but not super exciting. But the scientists analyzing this planet then actually wanted to see what the star is like. The star, once again referred to as Bagdu. Now this is an orange dwarf, also known as a K-type star, a star a little bit smaller than our Sun, but a star that seems to be much older. And so here the scientists wanted to find out what stage of the lifetime this star was in. For this they use a very well-known technique that you can learn more about in the description, known as astroseismology. This is actually a super cool technique based on the idea of seismology on planet Earth, where essentially by detecting various oscillations in a typical star, it then becomes possible to analyze what's happening on the inside. In some sense, it's like looking at star quakes. And this technique has been developing and improving pretty much every year, mostly based on helioseismology coming from our own sun. So first by studying the Earth, and then by studying the sun, it then becomes possible to study other stars. And that's essentially what the scientists in this study decided to do. And the main goal here was to try to figure out how old the star was and what period of its lifetime it was currently in. Turns out this was an extremely old star, basically almost at the end of the life cycle. And so by using astroseismology and looking at frequencies of waves coming from this particular star, it then becomes possible to find out what material the star is currently burning. And turns out that it's currently burning helium. And if the star is burning helium, it means that at some point it must have been much bigger. Based on modern research, we believe that helium burning process in these types of stars happens after the red giant stage that must have happened sometime in the past. And for stars like Bagdu, they're expected to reach a certain size when they become red giants. This is actually very similar to what our sun is going to become in the next 5 to 6 billion years. And so by doing the calculations based on the type of the star, K-type, the researchers determined that it should have actually been at least 0.8 astronomical units in size. Or in other words, it should have covered the star's orbit, completely engulfing the planet in the process. In other words, at some point in the past, this planet should have been inside the red giant star. Yet somehow the planet survived, suggesting that it now entered the next stage. And the challenge here is, of course, how exactly did this planet survive this? And why is it that we're not seeing this more often in other systems? Well, the first, I guess, the obvious question was, well, was this planet even real? Maybe it was some kind of a data glitch and maybe this planet doesn't even exist? Or maybe something else was miscalculated. But turns out after years of research, this planet has actually been confirmed to exist and seems to be the size and the mass that was originally suggested. The star and its current stage, which is helium burning, has also been confirmed independently, essentially confirming that there's a planet that somehow managed to survive what we usually believe destroys planets. In the end, assuming a relatively circular orbit relatively close to the star. Here, as you can see, the star is actually really large in comparison to the planet. And by the way, in case you're wondering, this particular helium burning stage is most likely going to last for a few million years. Although because this is a K-type star, it might actually last up to 50 million years. So this planet is going to be here for quite some time. Eventually though, the star is going to release the entire outer shell as a nebula and become a white dwarf. Also, this is not the first planet discovered around a red giant stage, but it seems to be the first so far that's close enough to the star and should have technically been swallowed and destroyed. So definitely an intriguing discovery and definitely a very intriguing mystery. But do we have any potential explanations? Well, at the moment, nothing too concrete and nothing that seems to explain everything. For example, one of the explanations suggests that maybe this used to be a binary system. This could have been two stars that had a planet orbiting very close to them, and eventually these two stars merged, preventing any one of them from expanding large enough, and thus preventing the planet from being absorbed. But by itself, this would be very difficult to prove, and there's really no evidence for any of this happening otherwise. The explanation itself would go as follows. We had two stars with a relatively close orbit, which would eventually start sharing the material, with one of the stars eventually becoming a white dwarf, and then the second star eventually swallowing the white dwarf, becoming the merged star that we see today that seems to have helium ignition that might have begun a little bit prematurely. Now that's a pretty intriguing explanation, but right now there's just not enough evidence. But the other explanation is a little bit more intriguing. The implication here is that maybe this particular planet formed as some kind of a remnant from the material that was expelled from the star, possibly once again because of a collision between two different stars or because of some other violent event. In other words, the suggestion here is that this is a second-generation planet. It's a planet that was created at the end of the star system from all of the extra material that used to orbit around the star and got expelled in the process when the star became a red giant. A pretty intriguing explanation, but once again, there is just not enough evidence to prove any of this definitively. And so at least for now, this is going to be one of those exoplanets that's not really going to have a very good explanation for why it exists or why it was able to survive. It's kind of funny, but you'd think that with more telescopes and better technology, would actually be solving all of these astronomical mysteries left and right. But it seems to be quite the opposite. Instead, we seem to find more and more, pretty much on a monthly basis. And one such unexplained mystery was discovered back in 2018. This unusual explosion you see right here, referred to as AT-2018 COW, or basically the COW for short, in essence created a completely new mystery that right now has no explanation. A new type of an unexplained explosion that seems to be extremely powerful, but also seems to be extremely fast, and very often containing a lot of blue light. And as a result, these unusual explosions today are referred to as the FBOTs, Fast Blue Optical Transients, or sometimes as LFBOT, where L stands for luminous, because they seem to be just as bright as a typical supernova and can be seen from very far away. And though this detection back in 2018 is still not really explained, since then a few more discoveries have been made by scientists using different types of telescopes, with one of the recent ones discussed in a video in the description. But now the scientists discovered something else nobody expected. Another transient, another unusual explosion that didn't just happen once, but actually seems to repeat over and over and over and over and over again. And that kind of makes no sense. And so, hello info person, this is Anton. Today we're going to discuss FBOTs once again, briefly discuss what the scientists think is happening here, and talk about this recent detection as well. But first, I guess a brief overview. So here's what we think a normal supernova usually looks like, and here's the one that involves some kind of a collapsing star that usually produces gamma ray bursts. You can learn more about GRBs in one of the videos in the description. But here's what the scientists kind of think might be happening around FBOTs. Almost like a mixture between the two. Potentially some jets, maybe some turbulence, very likely a lot of magnetic interactions, and most importantly, a huge amount of power. Or at least that's what the scientists thought at first, based on the first few detections. But further analysis of each of these FBOTs discovered something unusual in all of them. For example, the first one, the COW, turned out to be very flat, sort of resembling something you would see in a science fiction movie. It wasn't really clear why this is so, but the video in the description provides a few explanations. The next one, known as Koala, turned out to be very hot, approximately 40,000 Kelvin. The third one, for some reason, had very powerful emissions with material moving at approximately 55% the speed of light. Surprisingly, there was nothing unusual about the fourth one, but the fifth one turned out to be extremely bright in the X-rays, 200 times brighter than anything else before. The most recent one, the Finch, described right there in one of the videos, happened in the middle of nowhere, far away from any galaxy. But the one that was detected last year, today referred to as Tasmanian Devil, because of TSD I guess, at first was believed to be somewhat usual as well. And that's until recent examination by all of these scientists who wrote the paper you can find in the description. And here they discovered something super unusual. As a matter of fact, nothing like this has ever been seen before from anything. Here once again this was picked up by an automatic system that was able to see a sudden change of light. In this case though, this light was approximately 1,000 times brighter than a typical supernova. But normally with supernova, we kind of see the same results. In every single case, when a supernova happens, the luminosity graph resembles something similar to this. Essentially it becomes brighter and brighter for a few days, reaches a peak approximately 2 weeks after, and then slowly diminishes in brightness over the next few months. This is common to both Type 1 and Type 2 supernova, and so normally this doesn't change very much. Now for most FBOTs, it was kind of similar as well, but usually much quicker. And so the first detection from this one was very similar as well. It lasted for about a few days and disappeared afterwards, in essence confirming another FBOT. So basically the main difference is that a supernova would last for maybe a few months, this one only lasted a few days. But something else was detected here approximately 100 days later. In December of 2022, researchers working on this particular object discovered another very strange emission. But this time it was not blue, it was more red colored, and just as powerful as the previous one. Basically suggesting that at least 2 emissions occurred from this particular object only 100 days apart. Okay, cool. But they kept looking and they looked at some of the older data as well, discovering multiple emissions from the object, some, surprisingly, only lasting a few minutes. And even more surprisingly, every single emission was just as powerful as the first one, suggesting that this unusual object was continuously producing super powerful explosions, more powerful than a typical supernova, over and over and over again, with at least 14 discovered as of today, making this super difficult to explain. On top of this, to make things even more difficult, it also produced a lot of X-ray and radio emissions afterwards for at least a few weeks. But that could actually provide a little bit of a clue. For example, the blue light that we saw originally in 2022 was very likely because of extreme heat. These are known as thermal emissions. But the additional emissions, especially the ones in radio waves or X-rays, are actually the result of the interaction with the environment around this object. So for example, when some kind of a powerful jet or very powerful particles strike the gas around this object, they're going to end up producing a lot of different afterglows. Although what exactly caused the red color is currently unknown. And because this galaxy is relatively far away, over 3 billion light years away from us, trying to answer this is obviously not easy. But right now the assumption is that most of these emissions probably came from extremely strong magnetic fields. And more importantly, because some emissions were very short as 20 seconds, it sort of puts a limit on the size of this object. Since we have a limit to the speed of light, it's quite likely that this object cannot be bigger than approximately 0.1 astronomical units, approximately 15 million kilometers. But nevertheless, whatever this is, it was able to produce 14 supernova-like emissions, or even 1,000 times brighter than a supernova, in just 120 days, but also providing data in different frequencies of light. And so it's actually quite possible that because of this very strange object, we might be able to finally solve the mystery of F-bots by observing what happens here, with the best suggestion right now being either some kind of a black hole or a neutron star, possibly creating super powerful jets that then essentially resemble a supernova-like explosion and additional after effects as the jet interacts with the gas near it. But the reason these emissions are so powerful is because of the amount of accretion that seems to happen around these black holes, or neutron stars. So maybe the star in this case is actually not in a stable orbit, but instead has a very unusual orbit, or potentially has an orbit where it's going to collide with the black hole, where something causes these very abrupt, very bright flashes of light, only visible for a few days. And somewhat similar emissions or somewhat similar flares are sometimes observed from various active supermassive black holes, with the brightest flare, or the brightest emission, potentially happening when the star finally collides with a black hole or a neutron star, releasing a huge amount of energy all at once. But because some of the material is still going to be orbiting around the black hole, it's possible that we're going to be seeing more emissions over time. Either way, whatever is happening here, it's quite likely that this object is going to provide a lot of new data in the next few months. It's also quite likely that we might see even more of these unusual flares, and if they look slightly different and diminish over time, it will confirm the idea behind a star colliding with a black hole or a neutron star. But only time will tell exactly what's happening here, and at least for now, F-bots are going to stay as a new mystery that at the moment nobody can solve. In the past few years, we've discussed quite a lot of unusual stars, but normally these are stars that are maybe somewhat different, with certain properties that might be difficult to explain, but nothing too extreme. Stars that might be a little bit too hot, a little bit too large, or potentially a little bit too active. Now, today we're discussing something slightly more extreme. Actually, very extreme. A star system with what seems to be the largest tidal waves ever seen. Enormous tsunami-like formations that happen every few years, but are ridiculous in size. Completely incomprehensible by any Earth standards. Something that was once again discovered completely by accident, but something that might help us understand how stars evolve. And so, hello wonderful person, this is Anton. Let's discuss this unusual star system and what exactly is happening here, why it's happening, and basically break down everything we know so far. But I guess first, how was this even found? And interestingly, the star system was originally found when scientists were looking for dark matter. This was a project with a funny name known as the Macho Project. And what this project was trying to achieve was basically discover dark matter science by trying to identify minute gravitational landing effects coming from various objects right here in the Milky Way. This project was going on for about 7 years between 1992 and 1999, but as you might already be aware, it did not solve dark matter problems. it didn't really discover anything major, but it put some limitations on what dark matter could be. And because it was looking at gravitational microlensing effects, it was essentially looking for sudden, unexpected increases in brightness, which usually happens when a mass passes in front of a bright object, suddenly increasing its brightness overall. This is of course a very well-known effect and has been studied for many decades now. But one of the discoveries here was basically a typical star system. A star system whose name you see right here, that was actually studied by several scientists previously, and was eventually discovered to be what's known as a heartbeat star. A type of a binary system where two stars orbit with very eccentric orbits, and because once in a while they approach each other really close, they end up causing a lot of tidal disruptions on each other's surfaces, thus changing the overall brightness of the system as each of the stars changes their original shape. And so they'll produce a kind of a pulsation very similar to a typical heartbeat, just because they generally change each other's brightness with every single approach. So this is a type of a pulsating binary star. These are not particularly unusual by themselves. I guess just to give you a bit of a visual explanation here, so this is what a typical binary would look like. And here's one with two stars with very eccentric orbits. Technically these would be heartbeat stars. Stars whose orbits at some point approach close enough to cause dramatic tidal disruption on each other's surfaces. Now this is something that's not very common, but it does happen depending on the overall architecture of the star system. But normally in this type of a star system, the overall change in brightness is not really that large. Even at the closest approach, the powerful tidal disruption increases the brightness by less than 1%. And though there are some exceptions, overall it's usually not really dramatic. But when looking at this star system, scientists discovered that the brightness here changes by about 200 times more than in other star systems. Here the brightness goes up and down by about 20%. Or basically the star dims and then becomes brighter by about 20% every once in a while, actually with very specific periodicity. And with all of this lasting for approximately 2 days. And when originally discovered, this created a huge mystery. Nobody could figure out exactly what's happening here and why these stars are changing their brightness so much. And ironically, because of these strange observations, instead of a heartbeat star, it's now been nicknamed Heartbreak Star, which will make even more sense when we start looking at some of the initial explanations. Although at the moment all this is only based on computer simulations and not detailed observations or detailed evidence. Either way though, the explanation is very interesting. Here, as always, we have two stars, but the larger star is really big, possibly 35 times the mass of the Sun. And at some point during the closest approach, both stars start to affect each other, creating dramatic tidal effects. Now on planet Earth, obviously the Moon causes tidal effects, raising the levels of water by maybe a few meters in certain locations. One of the most extreme examples is actually in Canada. Here, the tidal range is approximately 16 meters, which is one of the most extreme tides anywhere on the planet. But that's nothing compared to what happens around the star. These two stars stretch and distort each other so much that the smaller star causes humongous waves on the surface of the bigger star, with the size of the waves being approximately 1/5 of the star's radius. Let me say it again, 1/5 of the star's radius, that's about 35 solar masses. That's over 4 million kilometers in height, or as big as approximately 3 suns. Just to give you another visual comparison, there's Earth, here's the Sun, times 3. With these absolutely ridiculous waves, very likely having very similar features to what we usually find in tidal waves on planet Earth. Just like ocean waves, they very likely start as smooth hills, eventually curling and breaking in a similar fashion, except obviously this is not water, and is mostly made out of plasma containing hydrogen and some helium. And just like the waves on the planet, they probably also leave a huge foamy mass once the wave passes, essentially causing the star to disturb its surface and to thus change its brightness quite dramatically, with all of this potentially producing at least a few more effects. For example, the surface of the star potentially starts to move a little bit faster, making the star spin a little bit more as well, while also causing a lot of stellar gas to swirl around, to move around in different ways, and to possibly even escape the star, creating massive emissions, which probably leads to a huge mass loss every time the stars come close to each other, but also a potential mass transfer that makes the smaller star a little bit bigger and the bigger star possibly a little bit smaller. But more importantly, it releases an enormous amount of energy. All of this tidal energy is essentially converted to kinetic energy, with all of this happening once a month. This even changes the shape of the bigger star, creating a bulge that's about 50% larger than the poles, with the unusual observation of glow on the surface implying that this is actually the signs of those waves breaking right on the surface of the star, in essence representing one of the most extreme examples of binary systems, or binary pulsating systems, also known as heartbeat stars, seen anywhere ever. And out of approximately 1,000 such stars known to us, this is the only one with such extreme deviations, and there seem to be only 20 with overall large changes in brightness. Other ones are usually very mild. But chances are that because this star was discovered completely by accident, this is maybe a very typical type of an object. It's unlikely to be super unique, but discovering other similar objects would very likely require additional observations using similar techniques, involving changes in brightness that make no sense. And so at least for now, this is definitely the most extreme heartbeat star, and definitely one of the most extreme binary systems ever detected. Something we'll discuss more once there are more observations or additional discoveries from this unusual system. So let's start the video right here around Venus. You're probably aware that Venus is already really hot, but it's actually supposed to be even hotter. Even though the average atmospheric temperature here is about 460 Celsius or about 870 Fahrenheit, because of the proximity to the sun, very thick atmosphere and all of the CO2, the temperature here is supposed to be much higher. I remember doing some calculations and it's actually something like 800 Celsius on average. And the reason Venus is much cooler than it should be is because of what's known as albedo, the property of reflectivity of a certain object. Although albedo by itself comes from the root alba, which means white, so it can also be described as the whiteness of the object. And because of various aerosols in the upper atmosphere of Venus, it's very reflective. Its albedo is approximately 0.76, which is one of the main reasons why we don't even see the surface. But obviously it's not really a mirror, because the light that's reflected here is more or less diffuse. I mean, technically you could use computer simulations to try to work out the original image that's reflected here, but because all of this involves very unpredictable atmospheric conditions, this would not be very easy. The point here is that 76% of all light striking the upper atmosphere is reflected back into space, making this the most reflective planet in the solar system. In contrast, Mercury is extremely low in albedo and does not reflect much, and our home planet is somewhere in between. The average albedo for Earth is about 0.3, although here things do actually differ quite a lot depending on what you're actually looking at. So for example, things like snow and ice are approximately 80% reflective, which is why the more ice there is, the more the planet reflects the heat, and the more likely it's going to maintain cool conditions. Intriguingly, this is also one of the reasons why during the glaciation period, it was very difficult for Earth to warm up to melt all the ice. It was just reflecting all of the light. In contrast, water does not reflect as much, and is thus able to absorb more heat. Then we also have clouds that do reflect things as well, and so for places like Earth, the albedo effects are actually extremely dynamic, and play a very big role in maintaining atmospheric temperatures or in dramatically changing conditions on the planet. Okay, well that's the solar system. Hello wonderful person, this is Anton. Today we're going to be discussing something else discovered really far away that the scientists are now describing as the most reflective exoplanet discovered so far, although the press release from the European Space Agency unfortunately used the word mirror. Yeah, no, that planet does not act like a mirror at all. It has a very high albedo, but it's not going to be producing a picture of your face if you look into its atmosphere. Anyway, so what exactly was found, and why is this planet kind of exciting? So once again, this is one of those planets that technically shouldn't exist, or at least it's a planet that we didn't think would exist. It's approximately 4.7 times the radius of planet Earth. It's also about 29 times as massive as Earth, so in some sense, it's what's known as hot Neptune. It's actually orbiting around its parent star at a relatively close distance, with a single orbit of just 19 hours. But its size to mass parameters are not really very common. This is actually one of the rarest planets discovered so far. But most of its features are probably due to its extreme heat. Temperatures of 2100 Kelvin, or about 1800 Celsius, 3300 Fahrenheit. Right now this is believed to be the hottest such planet ever discovered. not the hottest planet, just the hottest hot Neptune. But the reason the scientists think this planet should not exist or was never found before, or why this planet is in so-called Neptunian desert, is because if you look at the mass to orbital period distribution, you're actually not going to find any Neptunian planets in orbits very close to the star. And here it's defined as an orbital period around the star of less than 4 days, where these ice giants or Neptunian planets receive huge amounts of radiation and thus most likely cannot retain their relatively light gas atmospheres, eventually evaporating, leaving behind some kind of a core. These cores generally have a name. They're known as Chthonian planets. You can learn about previous discoveries of these unusual planets in one of the videos in the description. And so having these gas giants, similar in mass to Neptune, orbiting so close to the star is technically completely unexpected. Yet this object, known as LTT 9779b, seems to be there, at a distance of 260 light-years away from planet Earth, and more importantly, producing relatively strong albedo. In case you're wondering how this was discovered, here what the scientists usually do is observe the planet as it orbits around the star, noticing these slight changes in brightness. But in this case they realized that this planet was actually reflecting a lot of light, almost definitively suggesting that this was a planet with a albedo of approximately 0.8 or even higher. So about 5% higher than Venus. But it is generally very similar to Venus in its overall albedo and possibly even in its appearance. Both planets are expected to have very similar whitish atmosphere if seen from the outside, although in case of this exoplanet, because its temperatures are much higher, it's also most likely glowing in a relatively dim red light, especially on the far side of the planet. But overall it might look something like this, possibly a more reflective, shinier version of Venus, but also dramatically larger in size. It's even larger than Neptune actually. But the question here is of course, what's happening with this planet, why is it so reflective, and how is this planet even possible? Well, the only explanation right now that makes sense is in regards to the clouds that seem to circulate around the planet and the atmospheric content. It's unlikely to be similar to Neptune or Uranus or any other common gas giants. It's actually extremely likely to have clouds made out of heavy metals, things like for example titanium, and even things like silicates or basically rock. With the current model suggesting that there are several layers, one being titanates or gas of titanium, another one being silicates or particles of glass circulating above, which has two potential effects. One is the increased albedo or reflectivity of the planet, and two, because this gas is much heavier, since it's made out of bigger atoms, despite the proximity to the star and despite this being a gas giant, it's able to create a permanent atmosphere that does not escape and actually stays around the planet, forming a very unusual cloud deck. And here honestly it's even difficult to imagine what any of this would look like. We essentially have a gas giant that contains silicate and metallic atmospheric conditions, with these metallic clouds allowing this planet to become so large and to then also become so reflective. But since this planet is also slightly more massive than Neptune, it also has more gravity to hold on to a little bit more atmosphere. And so it's most likely a combination of different factors that allows this planet to physically exist and to possibly even maintain permanent atmosphere without losing too much. It's also quite possible that this planet was a lot larger before and potentially contained a lot of other gases, but they probably escaped over time, especially as this planet migrated across the star system and moved closer to the star. Because that's probably what happened here. It's quite unlikely that this formed so close to the star, because if it did, there's really no explanation for how this could have happened. And so even though at these temperatures we do expect the atmosphere to completely disappear through evaporation, it's clearly not happening, and the planet is real and definitely seems to have a very thick atmosphere, inflated to almost 5 times the size of planet Earth. But if it's the amount of these metallic elements that allows this planet to exist, where exactly did all of these metals come from? Generally we don't expect gas giants to contain that many, so there's maybe a chance that it did involve some kind of a planetary collision. Or maybe it basically ate one of its smaller neighbors, which could have also resulted in the change of orbit, making the planet approach much closer to the star. Although naturally, similar metallic conditions and metallic atmospheres have been seen around much more massive planets similar to Jupiter. It's just a little bit more difficult to explain when the planet is less massive, and especially when the planet is very similar to Neptune or Uranus. So definitely a pretty unusual and a pretty cool discovery. But when it comes to albedo, or I guess being a mirror, yeah, no, it's definitely not a mirror. And its albedo is not even that surprising either. As a matter of fact, there's an object in the solar system whose albedo is much higher. More than one object actually. For icy objects like Enceladus, the moon of Saturn, the albedo is about 1% higher than this planet. But the mysterious dwarf planet, known as Eris, discovered on the outskirts of the solar system, has an albedo of 0.9999%. This object right here reflects 99% of all of the light striking its surface. And most likely because of a relatively smooth surface, but also because of a certain type of ice that seems to cover the entire surface as well. It's actually not entirely clear why it's so reflective, but it definitely is. And so chances are, in the next few years, we're going to discover even more reflective planets out there, and something that's going to beat this record pretty quick. In contrast, you might want to check out the video about the least reflective planet discovered a few years ago, somewhere in the description. That planet was basically pitch black, and having such a low albedo is even more unusual. So imagine for a second if you could take the energy produced by the sun in a couple of days, and then combine this energy, releasing it in just a fraction of a second, sending it somewhere out there in the universe. And if someone out there billions of light years away from us were then to detect this, they would most likely see something like this. And if it was coming from many different directions from across the night skies, it would resemble something like this. And you might have already guessed what we're talking about based on the title or based on what I just described. We're once again talking about fast radio burst. Hello wonderful person, this is Anton, and today we're actually going to be discussing the strangest and the most unusual fast radio burst detected to date. The FRB that currently does not have a very good explanation and might actually create a few problems from some of the previous detections as well. The FRB that's actually visible right here. Originally discovered back in 2019, but officially analyzed and finally confirmed only a few months ago. And in case you've never heard of FRBs, well, welcome. We're talking about the biggest radio mystery in the universe. The signals coming from various directions across the night skies only lasting a fraction of a second, with currently no agreeable explanation that seems to explain all of them. Some of them seem to only happen once, some of them seem to be repeating, and some even repeat with a very specific sequence that has been discovered in at least 2 cases. With the most famous one being this one right here, known as FRB 121102. The FRB that seems to be quite regular in its appearance, and the FRB we've discussed on the channel in some of the previous videos you can find in the description. And since some of the original discoveries approximately 15 years ago, the scientists have officially identified and confirmed approximately 800 of them coming from various directions, coming from various galaxies, with many of them having extremely unique features and many of them still having no actual explanation. But I guess the best explanation is currently, well, that they're probably coming from some sort of a very powerful neutron star. And more specifically, a neutron star we usually refer to as a magnetar, the most magnetized object in the universe, that possibly contains something else around it that causes these signals to assume certain features such as very high polarization. Or maybe it's something entirely different, and because of this, it's basically a mystery. But in terms of features, many FRBs do actually resemble one another, and specifically they tend to have a lot of different frequencies in them. So here we're talking about higher and lower radio frequencies. And when one of the radio telescopes here on planet Earth captures one of these FRBs, the most important feature scientists usually look for is known as dispersion, with the second most important feature being polarization. And both of these features normally tell us about where the FRB came from and what sort of environment most likely formed this particular signal. But dispersion is slightly more important because it can generally tell us about the distance the FRB traveled. But what exactly is it? Well, it's essentially how dispersed the radio frequencies are when the signal arrives to planet Earth. When the signal is originally created, all of the frequencies are very likely traveling at exactly the same speed and are traveling as a single unstretched wave. But depending on the distance traveled, all of these signals are going to be traveling through a lot of different plasma. And once these signals start traveling through the plasma, some of the frequencies will actually be affected a little bit more than other frequencies. Specifically, lower radio frequencies will feel the effect more strongly and very likely slow down as they travel through a lot of this plasma, with higher frequencies generally traveling a little bit faster through the plasma and not being affected by the plasma as much. And in this case, it doesn't actually have to travel through some kind of a nebula. The plasma is located everywhere in the universe. It's basically the gas that seems to be present in pretty much most of the galaxies and even in a lot of intergalactic space. And so the farther that the signals travel, the more of this plasma they'll encounter, and the more it will cause certain signals to slow down and certain signals to continue going. And so by traveling billions of light years, these lower frequencies will be slightly behind the higher frequencies. And so when we actually catch these signals here on planet Earth, the resulting dispersion can then be used to determine the total length or the total distance traveled from the original source. As a matter of fact, because these signals tend to pass through various objects, it even becomes possible to study the universe in a lot of other ways, by possibly analyzing the total density, or by even trying to analyze the so-called dark energy or the expansion of the universe. So in other words, it's an extremely useful feature, making FRBs some of the most important signals out there. But then this paper came out, and the scientists discovered something really unusual. Discovered using China's 500-meter aperture spherical radio telescope, or basically the most powerful radio telescope we currently have. And well, first of all, out of 800 signals out there, this is only one of 24 known repeating FRBs. It seems to have repeated 75 times over a span of 6 months in 2020 alone. Or in other words, it does this, although this is obviously much faster than in real life. A single blink here would take roughly a few days. But upon the original discovery, the scientists used some of the other telescopes to try to see if they can identify more detail. And so they used the Very Large Array, a radio telescope in New Mexico, to try to pinpoint the exact location where all of this was coming from. Turns out it's a dwarf galaxy approximately 3 billion light-years away from planet Earth. But more interestingly, they also found a persistent but much fainter radio signal that's emitted from a very similar region. In other words, something else was emitting signals here as well, and that something else could be responsible for the formation of the FRB as well. Now to date, only one other source has been discovered with a very similar feature next to it, making this already a super rare object. But then it got even stranger. Here the scientists wanted to discover the distance using the dispersion method I previously mentioned. Essentially by measuring the lower frequencies and higher frequencies, they could then try to estimate the distance traveled by the light. And to their surprise, they discovered that the calculations suggested the distance was about 10 times farther away. In other words, it was about 30 billion light years away from planet Earth. Making this sort of a problem, because it means that either the dispersion method is maybe not as accurate as we initially thought, maybe the signal is passing through a lot of different gas that's otherwise not available in other detections, maybe this is a signal that's just passing through this galaxy and there are actually two different signals here, or maybe there's really no explanation for what's going on just yet. And because the dispersion method has been previously used for a lot of other FRBs to try to estimate their distance, it actually sort of creates a major problem for a lot of different studies. If this method is not accurate at determining the distance, it means that a lot of previous studies will have to find another way, or possibly even completely revise their original data and their original analysis. But there are actually 19 different FRBs with known locations and distances determined using this particular technique. And in case of these other 19 FRBs, their distances seem to be similar to the original source, the original galaxy. In other words, it's really this particular FRB that seems to be the unique one, or I guess the one that's causing a lot of problem. And so, what exactly is happening here? Is it because of something extremely unusual happening very close to the FRB that's causing a huge amount of plasma forming in the region? Is it somehow related to this unusual other radio source that's somehow responsible for causing the dispersion that would be much smaller otherwise? Or is something really strange happening inside this galaxy, or maybe between the galaxy and planet Earth, that's causing the dispersion to be so dramatic? So at the moment, nobody knows, but it basically adds another extra layer of mystery on top of the already big mystery of the existence and origin of the FRBs, and what's actually causing so much diversity amongst them. And so at least some of the explanations might actually suggest that FRBs are just not really the same phenomenon at all. They come in different shapes and sizes. And so right now the scientists are hoping to study the same FRB using several other radio telescopes in order to actually see what's going on and to get more data, helping them identify the actual issue. And so if all FRBs are actually caused by the same phenomena, the only other explanation is that maybe it's just at different stages of evolution. For example, if these are related to neutron stars or magnetars in various galaxies, maybe the magnetars in this case go through some dramatic shifts in their magnetic field and dramatically change the environment around themselves in order to cause certain FRBs to look entirely different from other FRBs. Or maybe something else is causing the dramatic changes in the dispersion that the scientists have never considered. For all we know, maybe it's not even coming from the magnetar itself, but instead is something more fundamental that's not really understood in the universe. once again making this a pretty interesting mystery and something that I'm sure we'll be coming back to in the next few months and in the next few years. This mystery has been going on for a few years now, and I've always been super excited to report on new studies and new discoveries. So make sure to subscribe because we're definitely coming back to this in some of the future videos. It's absolutely incredible how far astrophotography and modern amateur astronomy has come in the last few years. And I think nothing exemplifies it better than the recent detection that just appeared a few days ago. Hello wonderful person, this is Anton, and today we're going to be discussing this recent observation coming from a lot of amateur astronomers around the planet of essentially the closest supernova seen in the last few years and the second closest in the last 10 years. With the only supernova that was even closer to us being the one you see right here from back in 2014, from the galaxy known as M82, also referred to as the Cigar Galaxy. But this time it's something slightly farther away, 21 million light years away to be more exact, and it's a supernova from M101, the iconic Pinwheel Galaxy that we've actually discussed in one of the previous videos, because the James Webb Space Telescope also took quite a lot of pictures of this galaxy in the last few months. And what I've actually discussed in that video is that this galaxy is known to be relatively active. And it's also relatively large, possibly about 50% larger than the Milky Way and somewhat similar to the Andromeda Galaxy. But unlike the Andromeda and unlike the Milky Way, it contains a really high amount of what's known as H2 regions. The regions enriched in atomic hydrogen that's usually ionized and usually representing the location where star formation has recently taken place. This one is from the Triangulum Galaxy, but in the Milky Way and in the Andromeda Galaxy, these are not as common, because they're usually common in very active galaxies, especially starburst galaxies. And though technically Pinwheel Galaxy is not one of these galaxies, it does contain a huge amount of starburst regions, and a lot of H2 regions visible from far away. As a matter of fact, the ones in this galaxy are even able to form superbubbles, ridiculously large in size and extremely bright from very far away distances. In total, there are nearly 1,300 of these regions in this particular galaxy. And this of course represents the number of supernovae that happened in the past, which means that this galaxy is a pretty popular destination for amateur astronomers hoping to one day discover a supernova. And they do have a pretty good point to do so. There was a supernova here, a really bright one, back in 2011. But now we have a new one, the one that everyone is trying to take a picture of, and the one that's basically the brightest in the last few years. Moreover, apparently you can actually see it, assuming you have some kind of a small telescope or even powerful binoculars. And so that's pretty much the main discovery that I wanted to mention in this video. A new bright supernova that you can technically see yourself. And if you do want to try to find this yourself and try to see it with binoculars or a small telescope, assuming that you're in a dark enough environment, in essence you're looking for the Ursa Major constellation. And here, right at the tip of the Ursa Major, which might resemble something like this, you're trying to find a series of these three bright stars, Elliot, Mizar, and Al-Qaid, with the galaxy itself forming a kind of a triangle with the last two bright stars. Visible from this perspective if you look at it in a relatively small telescope. But with a large enough telescope, it should be possible to tell features apart, with one of these features inside one of the arms being the supernova itself. Now it's not going to look any different from a typical star, but if you keep coming back and looking at it every day, it will dramatically change in the next few weeks. As a matter of fact, as of the making of this video, it still actually is getting brighter, but at some point it's going to peak and then slowly decline in luminosity. With a lot of these features indicating that this is a Type 2 supernova, when a massive star explodes, leaving behind some kind of a black hole or possibly a neutron star. But when it comes to the actual discovery, that's I guess where things get a little bit more interesting, because all of this was entirely done by amateur astronomers, or as I like to refer to it nowadays, independent astronomers. First discovered by a Japanese astronomer, Koichi Itagaki, back in May of 2023, reporting it to everyone else afterwards. He's actually quite iconic in the amateur astronomy because he's discovered quite a lot of supernovae previously. Following this, we had a few more observations from other independent astronomers, and even the first image from the NASA's Swift telescope. In this case, these observations are in the ultraviolet light, and it looks like this supernova seems to be the brightest UV supernova ever observed by this telescope. And within just a few days, hundreds of different photos started to emerge showcasing the supernova from different places around the world. And mostly because it's actually kind of rare to find a supernova that's visible to independent astronomers using commercial equipment. The majority of supernovae we usually observe can actually only be seen by professional astronomers and usually using much more powerful equipment. But this one is expected to get quite bright and might even become brighter than the previous supernova from this galaxy, mostly because of its type. The Type 1a supernova that happened in 2011 reached a magnitude of 9.9. This one, being Type 2, might be even brighter. But even though this is a relatively recent discovery, we already have some details about what's happened here. For example, we know that it happened very close to another really prominent region known as NGC 5461, an easily visible and actually somewhat thick H2 region, one of the easier such regions visible from this galaxy. As I mentioned before, this galaxy contains approximately 1300 such regions, with NGC 5641 being interesting because it's somewhat elongated and even contains some kind of a stellar core, or basically a region enriched in stars. But this supernova happened slightly farther away, though still inside the galactic arm, and this of course indicates that this is most likely going to become a new H2 region sometime in the future, or potentially has a chance of becoming one based on how many other supernovae occur nearby. And we also know that this was very likely a star similar to Betelgeuse, possibly about 15 solar masses in mass, suggesting that it most likely left behind a typical neutron star, unlikely to be a black hole. And what's somewhat intriguing about this observation is the actual physical similarity of NGC 5641 and the supernova to the other iconic region in the Large Magellanic Cloud known as the Tarantula Nebula, and specifically R136, that also contains a similar stellar core and also contains a relatively large in size H2 region, but more importantly, not so far away from R136, back in 1987 we witnessed this, the closest supernova ever seen in modern times. And this was also a Type 2 supernova that left behind a neutron star that was discovered not so long ago, and must have happened in a very similar way to what we are now seeing from M101. Implying that this is extremely common, and of course confirming that we're more likely to find more supernova close to these H2 regions, especially the ones that are really prominent and really massive. Which is probably why this Japanese astronomer has so far been so active and so productive. He probably realized that there are certain regions around certain galaxies that are more likely to produce Type 2 supernova. But until future discoveries or until future analysis of the supernova, that's pretty much all we have. I guess it's just exciting to have an actual supernova you can see with a relatively cheap telescope, assuming of course you can find the galaxy by following the Big Dipper. And of course, following previous discoveries, it's quite unlikely that we're going to be seeing anything as bright for the next 10 years or so. And so if you do have a telescope, don't miss your chance. Hello wonderful person, this is Anton, and today we're going to be discussing a new mystery. And here's what it actually kind of looks like. The scientists currently refer to this as Sauron. Yep, the same Sauron from Lord of the Rings. Although in this case it's a bit of a play on word and it's actually an acronym. It stands for Steep and Uneven Ring of Non-Thermal Radiation. And at the moment it seems to be the first such object discovered in all of the data, but at the same time it seems to be somewhat similar to another very unusual phenomenon only discovered back in 2019. An extremely strange phenomenon referred to as ORCs, odd radio circles. The unusual radio phenomenon we've discussed a few times on the channel, and that even today still doesn't really have a very good explanation. But it seems to be absolutely giant, potentially several million light years across, and just as the name implies, it's only visible in radio light. It's invisible in the X-rays, it's invisible in optical light or the infrared. And there's a very limited way how these particular radio emissions can actually be produced. As a matter of fact, the only potential explanation here is what's known as synchrotron radiation, which usually happens when things like, for example, electrons suddenly change the direction of motion, most often because of magnetic effects, and then emit radio light as a result of this change of direction. Nevertheless, after 4 years of investigations, and 6 such objects discovered so far, we still don't really have any explanation of what's actually happening here. All of these ORCs, or odd radio circles, are bright in radio waves, but only 3 of them seem to contain optical galaxies in their centers. So maybe at least 3 of them were actually formed by galaxies. How the other 3 were formed is of course unknown. But back in 2019, even the detection of these objects was already a huge mystery. Nobody ever expected these objects to be discovered, and they were actually discovered completely by accident. In this case, the data came from the Australian Square Kilometre Array, the super powerful radio telescope currently operating in Western Australia. And so in that data, the scientists discovered several unusual objects approximately 1 arc-minute in diameter at very high galactic altitudes away from the galactic plane, with all of them resembling some kind of a spherical shock wave. But no current explanation, such as, for example, neutron star collisions, black hole collisions, galactic collisions, supernova, gamma ray bursts, or any other common emissions we usually detect, could explain what's actually happening here. And so in the end, the scientists realized that orcs must be a completely new type of an object and were basically the biggest mystery in astronomy, at least the biggest radio mystery. Even things like fast radio bursts had a few more explanations compared to orcs. But we obviously have more telescopes coming, including the giant Magellan telescope and the currently active Meerkat telescope located in South Africa, which of course means that we're getting even more data, radio data, that can allow scientists to discover even more of these unusual objects. And that's pretty much exactly what kind of happened here, except that there's one problem. New telescopes, new observations also mean ridiculous amounts of data. Here, just a single observation from the Meerkat can actually result in terabytes of data that then has to be analyzed by someone. And even though this is open to volunteers, normally not a lot of people actually are able to do so effectively, and normally most of this data ends up being unprocessed. And so the scientists behind this study came up with their own artificial intelligence, or I guess technically machine learning. They named it Astronomaly, I guess combining astronomy and anomaly. An algorithm whose main purpose is to go through data and quickly find out something unusual inside the data, something that just doesn't make sense, and specifically data that might have been overlooked by others. In this case, applied to the data from the Meerkat collected in the last few years. And, well, it did find something. And I think the title from the paper basically says what it is. A unique ring-like radio source with quadrilateral structure detected with machine learning. Basically, this. But because the previous objects were orcs, they decided to name this one Sauron. Which I guess means that all of the future radio discoveries that involve mysteries are probably going to have some kind of a Lord of the Rings reference as well. I can't wait for someone to name something Morgoth, Melkor, Shelob, Balrog, and of course, Frodo. Because, well, it's Frodo. And also apparently I look like him. Anyway, I'm actually super excited about future discoveries and future naming. As a matter of fact, maybe there should be a rule where any object that involves radio waves and is unexplained has to be some kind of a character or a thing from Lord of the Rings. Yeah, probably not gonna work. But I'm still going to be using these names anyway. And so they named this Sauron. But even though it might sound kinda cheesy, it does have a meaning behind the name. S stands for steep. In this case referring to the unusual spectral slope where the high radio frequencies very quickly grow fainter as they move away from the source. But UR in this case refers to uneven ring. That's because it's not a perfect ring, unlike a lot of other odd radio circles. And the last part refers to non-thermal radiation, referring to types of radiation produced by particles accelerating by powerful magnetic fields, but possibly not by anything else, because nothing else seems to be happening here. And currently this object is believed to be about 1.2 million light years across, 20 times the size of the Milky Way galaxy. But the question is it also an orc? Is it an odd radio circle? Well, at the moment it doesn't seem to be the case. It doesn't really have the same properties as odd radio circles. For example, with a lot of orcs, at least half of them do have a central galaxy in the middle. Here, however, the host galaxy known as Abell 209 does not seem to have any radio emissions like the ones where we usually find orcs. And more importantly, none of the wavelengths or the frequencies match the observation from Sauron. At the same time, its shape is very different as well. It's not really a circle. And as the name implies, it's basically four-sided, quadrilateral, which to the scientists behind this paper suggests that the magnetic field in this case might actually have some unusual properties. The fields here don't seem to align well with the main structure, and so its true origin is completely unknown. And even though it resembles one of the odd radio circles a little bit, they're still very different from a lot of other discoveries to date. And at the moment this seems to be one of approximately 200 different anomalies identified by the artificial intelligence, but only one of them resulted in something that seems to be definitely there. The only problem is that we don't really know what it is. Is it the result of a galactic collision? Is it a result of a black hole collision? Or is it something entirely different? There's really no way to actually know what it is just yet. Although at the moment, the best explanation so far is that maybe it is a result of a merger between two supermassive black holes millions of years ago, specifically located right in the middle of Abell 209. But in order to actually establish if this is what happened here, we have to find other signs. Usually these also involve a lot of emissions, including a lot of star formation and very powerful accretion disks around a central black hole. At the moment, nothing like that has been discovered here just yet. But the only explanation for what we're seeing is really powerful magnetic fields. No other physical phenomenon can create anything like this without producing other emissions. There's no optical light, there is no X-rays, there's no gamma rays, there's nothing. Just radio light. So it has to be a very powerful magnetic field, but in this case a field that stretches across millions of light years. But then again, that's pretty much exactly the same problem with trying to explain orcs. We still don't really know what happened here either. I guess the only difference is that these are a little bit more circular, and usually are actually associated with some kind of a galactic center. This, however, is not. But chances are we're not going to know what it is anytime soon. This thing is about 7 billion light years away from planet Earth, so it is actually pretty far, and even the most powerful radio telescopes right now are going to have trouble discovering what actually happened here. And this was also the only discovery out of approximately 115 galactic clusters, with each containing thousands of galaxies. The observations here lasted for approximately 1 year, which basically suggests that these are not very common objects, the only one out of potentially 100,000 galaxies investigated so far. And so whatever is happening here is just going to be yet another radio mystery to add to the book of various other radio mysteries discovered in the last few years. So far there's actually quite a lot, and you can find more in the description below. Apart from orcs, we obviously also have fast radio bursts, and some other phenomena you can discover in the description. Anyway, for now that's pretty much all we know. It's a completely new discovery, it has no explanation, it has pretty much nothing, except for I guess a cool name. Hello wonderful person, this is Anton, and it looks like for the first time ever, the scientists officially discovered a star consuming a planet. Finally discovering evidence that a red giant somewhere out there most likely ate one of its planets relatively recently. Something that the scientists have always predicted to happen, and something that might happen in the solar system, but something that's never actually been physically seen. Until of course now. But this is just an illustration, because in this case, the observations themselves relied on unusual observations coming from the star system you see right here, whose unusual emissions that resembled some kind of a strange nova turned out to be something entirely different when the scientists analyzed the gas. It looked like all of this emission and the unusual brightening was essentially the result of some of the material from the star temporarily increasing the luminosity of the star to make it appear as if it had a nova, which is of course how they initially were able to discover this event. But let's discuss some of the details and what all of this means for astronomy. But let's start with the obvious. This is basically like looking into the future of our sun. We know that the sun is also going to become a red giant a few billion years in the future, beginning its red giant stage approximately 5 billion years from now. And at that point it's going to grow larger and larger, losing a lot of mass, engulfing some of the planets, especially Mercury, Mars, and very likely Earth, and dislodging some of the other planets, changing their orbits in the process. And this happens because the star runs out of hydrogen and starts fusing helium into carbon. But that's hydrogen in the core. The hydrogen on the outside ends up migrating to the outskirts and starts to fuse there as well, causing the expansion. So basically it transforms the star and the fusion in the star from just having hydrogen inside the core to now fusing helium inside, but also hydrogen on the outside. Although certain types of red giants don't even have helium fusion and only have the hydrogen fusion on the outskirts, which is essentially why they turn so big. And though the size increase takes a few thousand years, this stage itself can actually last for a pretty long time, more than 100,000 years in certain stars. Enough time to start consuming planets that might be a little bit too close. But the actual process of that consumption is not of course well understood because we've never really seen it. We've seen certain stars that are just a little bit too close to their stars, but never inside the envelope, until of course now. And this particular simulation that you see right here, to some extent explains what might have happened here, as this planet was basically moving extremely close to the surface of the envelope. And so during this event that the scientists now refer to as ZTF SLRN 2020, several ground-based observatories detected unusual brightening visible in the optical light and the infrared. And as I mentioned previously, at first the scientists thought that this was some kind of a nova. And more specifically, a red luminous nova, usually a result of merger of binary stars, such as the one that you see right here that happened in V838 Monocerotis. They normally contain exceptionally low optical luminosity, but do produce a lot of infrared light, producing a lot of beautiful emissions in the process. This, of course, was an iconic event studied by various telescopes for several years. You can check out more about this in one of the older videos in the description. And so Caltech's ZTF, or Zwicky Transient Facility, that's actually really good at detecting various nova and supernova, discovered this unusual brightening a few years back, but it wasn't analyzed until now. And normally, nova involves some kind of a white dwarf, which usually ends up releasing a lot of hot gas, which can be then observed with additional telescopes. And this gas is generally extremely hot. But in this case, when the scientists looked at this using other telescopes, they discovered that the gas was much cooler. It was actually the coldest gas they've ever seen, basically making these infrared observations extremely unusual compared to anything else. Here they expected to see a lot of heat, yet it looked like whatever happened here was most likely not a typical nova. And by looking at data from NEOWISE that's able to produce a kind of a timeline of infrared change, they found evidence of a lot of dust forming around this unusual star, but not the gas expected from a nova. And because only a few things out there can create such unusual infrared light, followed by brightness in optical light, this suggested that the scientists might have discovered an event we've never seen before. And since the star was also seen to be brightening a year before that, the only possible explanation was that something must have fallen into the star. But also very likely it didn't just fall right away, but orbited around the star for at least a year. And each single orbit produced newer observations and newer emissions, in essence creating a kind of an unusual infrared glow visible from really far. But once it actually fell into the star, that's when things get really interesting. Right after this, the optical brightness increased by approximately 100 times, and it stayed that way for at least a week. And so the combination of that infrared emission followed by optical emission was pretty much a telltale sign that this was some kind of an event involving most likely gassy object. And based on the observations of total energy released, the scientists believe that this was most likely something that's even more massive than Jupiter by possibly as much as 10 times. And I think here the actual surprise came from the effects this planet had on the star itself. And so first of all, it must have started when the atmospheric drag from the star started to shrink the orbit of the planet enough to make it come closer and closer. With this process lasting for several orbits, with the planet actually plowing through the star and pulling a lot of gas from its surface, sending it away into outer space. With all of this gas slowly moving away from the star and most likely turning into something very similar to snow and water vapor. And during that final event, when the planet submerged into the star, even more gas was released from the star, possibly because of this very massive object suddenly falling into the star, creating a major disturbance on the surface, with the energy transferred from the planet to the star, making the star expand and become much brighter. But the more recent observations discovered that the star is now back to normal, making this a temporary event, even though the event prior to this lasted for about 100 days. And during those 100 days, approximately 33 Earth masses, in terms of hydrogen, were released into outer space, and approximately 0.3 masses of planet Earth released as other types of dust. Although obviously once the planet collided with the star, the total mass of the star increased just a little bit, with a lot of this material very likely now being somewhere in the outer space and potentially forming some kind of a shell around the star. And so to some extent that's maybe something that's going to happen to the solar system in the future, but none of this will be as dramatic. As a matter of fact, it's quite unlikely our sun is going to increase in size and brightness as much, or even at all. Here the planet was a lot more massive. But because the scientists today predict that at least a few of these events happen in the Milky Way every single year, now we sort of know what to look for. We might be able to discover even more in the next few years. But there's obviously one more question here that we cannot answer. What exactly happened to the planet? Now, I mean, you would assume that it's going to get swallowed and possibly recycled, but it's most likely not going to happen for a very, very, very long time. As a matter of fact, for many thousands and millions of years, The super hot remnants of this planet are most likely going to be circulating inside the star, inside its envelope, approaching the core much closer, and potentially influencing the star in some other ways. There's another video on the channel that you can find in the description that explains various unusual phenomena from certain stars, very similar to what we just observed from this particular star system. So in other words, the planet is still there, it's just really hot, and is going to remain that way for a pretty long time. But it will definitely have more effects on the star, which should be observable in future studies and future observations. Well, looks like it's another day, and another strange discovery from the James Webb Space Telescope. Something that the scientists once again are kind of having trouble explaining. 6 separate galaxies you see right here, very likely formed approximately 500 to 700 million years after the beginning of the universe, but the galaxies that are a little bit too massive, actually way too massive, creating a bit of a problem. Hello wonderful person, this is Anton, and so let's discuss this new publication and new paper that just came out, and talk a little bit more about exactly what's happening here, what the scientists believe is happening, but more importantly, discuss possible resolutions or possible explanations for why these galaxies could have existed so early on, or whether these are even galaxies. Although first, the obvious, so this is actually not the new discovery. As a matter of fact, the publication itself was already available back in July of 2022, and we did briefly discuss it back then as well. But what makes this paper interesting now is really the fact that it was finally published, peer-reviewed, and definitively confirmed to have something unusual going on in these 6 images. But here's the important part. Not unusual in a way that it breaks the Big Bang theory, or to some extent proves that the universe always existed, confirming what's known as the steady state theory, which I've discussed in one of the previous videos you can find in the description, but instead confirms the idea scientists have been discussing for the past few months. There was something going on in the early universe that allowed all of these ancient galaxies to grow, to combine, and to become bigger and more massive much quicker than anyone has ever anticipated. Or at least compared to the simulations such as the famous Illustris project that you see right here. So basically the idea here is that, well, the computers predicted this, but there might have been something missing in the simulation because what we're seeing is very different, or at least to some extent. And that is literally the purpose for the James Webb Space Telescope. It was kind of to see if the models were correct for the most part, or if there was something missing. And turns out, as it showed us, there's definitely something missing, which is of course what makes it so exciting. Had the James Webb Space Telescope confirmed everything the scientists have been modeling for the past few decades, well, it would probably mean that I would have nothing to talk about because every single video would have been, yeah, this is exactly what the scientists thought. Yet the last few months have been super exciting because a lot of the models have been so far shown to be kind of incomplete. Once again, important distinction, not wrong, not incorrect in any way, just incomplete. The Big Bang still stands, the universe is still expanding, which is exactly why we're seeing these galaxies as redshifted so much compared to everything else. But more importantly, all of the images we've been getting so far don't show us anything super unusual that would prove anything completely incorrect. They definitively show us though that there is a lot of stuff we don't understand. Science at work. Although as you probably know from some of the previous videos, this is not even the first time we talk about unusual galaxies found by the telescope. Once again, more videos in the description. This time though, the discovery is all about the masses of galaxies and I guess to some extent their size. All 6 galaxies discovered in this case, first of all, seem to be well formed, but more importantly seem to be pretty massive. One of them is at least 100 billion times the mass of our Sun, which is still maybe about 10 times less massive than the Milky Way galaxy, which is about 1 trillion solar masses, but presents a bit of a problem because nobody thought these massive galaxies could exist around the time when the universe was only about 500 to maybe 700 million years old. As you can see from this older model by NASA, the scientists used to believe that the first stars only appeared 400 million years after the beginning of the universe. So having these massive galaxies within about 200 to 300 million years, according to old models, would be impossible. But these models have already been reworked a lot in the last few years, and so everything you see here is already kind of outdated. Nevertheless, at the moment there's really no model that would explain how something so massive could form so fast. At the moment, the modern models predict that the first stars and some of the first smaller galaxies would have started forming around 150 million years after the Big Bang, which gives these massive galaxies only about 400 million years to develop into something mature, something possessing a lot of structure, and something already resembling some kind of a massive galaxy, similar to the ones close to us. And so if these galaxies were already very similar to the ones we have around us, it's kind of difficult to explain how they were able to acquire so much density of matter. It's as if something caused them to become extremely dense and extremely massive really quickly compared to everything else around them. Now, is that impossible? Not really. As a matter of fact, if we actually consider the fact that a lot of properties of the early universe were different, including possibly very powerful magnetic fields, it's definitely a possibility. We just have to rework some of the simulations used years ago. But I guess the other problem here is that the density of matter in these galaxies would be very different from the density of mysterious dark matter, especially in the halos of those galaxies, implying that they basically are a little bit too dense to maintain their shape and to maintain their size. And because there are 6 of them discovered so far, it means that this is not just some lucky galaxy with unusual properties. This sort of implies that it might have been kind of common. And one implication here is that, well, maybe the amount of total mass in the early universe was up to 100 times greater than anyone previously believed. That's at least one potential explanation. And if so, where exactly did all of this mass go afterwards? This would create a new mystery of even more missing matter. Another more obvious explanation here would be, well, this could be an error in calculation, especially because, in this case, in order to calculate the masses for each of these galaxies, the scientists had to rely on a somewhat older model that uses their overall redshift and brightness in order to estimate the potential mass. In other words, it's not like the scientists used some kind of a scale to measure their weight. There's a very big possibility that the model used in this case might actually not work with these really distant galaxies very well. But in order to assess if this is correct, the scientists behind this paper have already proposed that obtaining spectra of all 6 candidates will definitively reveal their nature, their distance, and of course their size in more detail. So even right now, this is a pretty big assumption. By seeing something like this, an actual chemical spectrum, like seen from several other galaxies, the scientists will know for sure. And it will definitely reveal exactly what the scientists here are looking at. They even have suggested that maybe these are not galaxies at all. Maybe these are entirely different objects. For example, they've proposed that this could also be some really strange, very massive black holes, producing extremely high amounts of radiation because of very powerful accretion disks. And if it is ultramassive black holes, that presents a new mystery, another mystery that will have to be explained in some other way. Which is why spectra observations will very likely be the next step here. At the moment, this is not available. But apart from being some really strange, never-before-seen black holes, or galaxies that formed a little bit too quickly and possess a lot of mass, these could also just be very exotic objects that only existed early on in the universe and do not exist anymore. You might want to check out the video on the green pea galaxies we discussed not so long ago that do talk about some of these phenomena in more detail. But once again, this could also just be an error, mostly because of the model used that sort of overestimated the mass. This is also actually mentioned in a paper with a potential overestimation by a factor of 100. But if these are galaxies, well, it once again means we just don't understand how galaxies formed early on, with some explanations maybe pointing at the mysterious cosmic web that basically guides and builds the galaxies over time, but also probably very powerful magnetic fields, which might have played a role in helping these early galaxies form much larger over time. Something that one of the recent studies has actually explored as well by looking at the magnetic fields of the cosmic web and how they tend to actually guide a lot of the material inside. And so what's the conclusion here? Well, as I mentioned back in July or August, whenever the scientists originally found these, finding these unexpected galaxies was always the main purpose of the James Webb. This was actually from the Cosmic Evolution Early Release Science program that was released in the summer of 2022. And the main goal of this program was exactly that, trying to figure out if the models of the universe evolution were maybe a little bit too primitive, and if the stars and the galaxies early on evolved in some other way. And now, months later, that's pretty much exactly what all of these galaxies, and of course all of these new discoveries, are sort of implying. Models need to be reworked, a lot of new observations have to be made to try to figure out exactly what's happening here, and more studies need to be conducted before any conclusions can be made. So once again, science at work. Hello wonderful person, this is Anton, and today we're going to be discussing yet another really impressive 3-dimensional map of an intriguing structure created by the astronomers relatively recently, showcasing what's known as the magnetic local bubble, which basically represents the magnetic field or the magnetic structure that surrounds the solar system and everything around us, and to some extent creates this unusual shape that you see right here, that also then produces quite a lot of intriguing effects on the surface of the bubble that have only been discovered in the last few years. But more importantly, this is an actual three-dimensional map that you can interact with, exploring each of the individual parts and each of the individual structures here, with some of the individual structures, and some of these individual structures we've previously discussed in separate videos that you can find in the description below. I think one of the more important discoveries in the last few years was the discovery of this unusual Radcliffe wave that you see right here, that represents this unusual ripple-like structure that many stars seem to surf on. The video in the description explains this a little bit better. But this recent map, this recent discovery, is going to help us answer a lot of really old questions about the origin of stars and the influence of magnetic fields in various galaxies. Because this is essentially a magnetic structure. What you see on the surface here, these are magnetic fields. And so what's actually coming from this recent study is the new technique or the new ability for the scientists to be able to actually see the magnetic field on the surface of this unusual local bubble. But I guess the first question is, what exactly is this bubble? And how did it even form? Well, because we're not really three-dimensional creatures and we're more two-dimensional creatures, I love using this map that you can find in the description that sort of shows us what everything around us potentially looks like. This was created by analyzing a lot of data from the Gaia telescope. Now this is in like tens or even hundreds of light years in distance, but if you start zooming in here, you'll discover this unusual feature known as the local bubble. There are a few smaller ones here and there, but the local bubble, or the local cavity as it's also known, is one of many different superbubbles located in the Milky Way. It's potentially at least 300 light years across and could be as big as almost 1,000 light years across. And as this bubble expanded over time, it pushed the interstellar gas away from the center, which then collapsed to form new stars on the surface of the bubble itself. The star that you see moving in the middle, that's basically our Sun. It most likely entered the bubble about 5 million years ago. And so the fact that we're almost in the middle of the bubble is sort of completely by accident. This bubble existed even before the Sun entered it. But it was most likely created by some kind of a pressure from some kind of an ancient supernova that potentially was caused by one of the stars located in the open cluster known as the Pleiades, also known as the Seven Sisters. This happened anywhere from 10 to possibly 20 million years ago, and as you can probably imagine, was an extremely powerful event. So powerful that it ended up creating this several hundred light years across structure. And even though the scientists recently discovered that a lot of stars definitely form along the surface of the bubble, with the expansion of the bubble creating the pressures needed for the stars to form, there are still so many mysteries about the structure, and of course its effects on the galaxy and all of the stars around us. But in all of the previous discussions of superbubbles and all of the previous models, the magnetic field for the most part was usually ignored. In other words, it mostly focused on the pressure or on the interactions of gravity on much larger scales. But most scientists are aware that this is not the reality. As this map shows us, the magnetic field here is quite prominent, and most likely plays a really important role in everything from distribution of gas, potentially guiding gas to various directions around the galaxy, or even forcing certain gas to form certain types of stars and certain types of molecular clouds. We've actually discussed various discoveries in regards to magnetic lines or magnetic fields in the Milky Way in some of the previous videos. Some of them should be in the description below. But in a nutshell, a lot of discoveries looking at all of this in radio light clearly established that the galaxies have really huge prominent magnetic lines, which potentially are responsible for a lot of effects we cannot explain. And so even though this particular supernova that happened 20 million years ago created a lot of powerful pressure, the magnetic fields that were created as a result also played a really important role. But what role? Nobody knows just yet. For example, they could definitely influence the overall shape of the galaxy, or at least the overall shape of certain molecular clouds. As a matter of fact, as I've discussed in that previous video, you'll notice that a lot of molecular clouds that produce new stars definitely seem to be located on the surface of the bubble itself. But some of them are located in the region with slightly different magnetic fields, at least based on these new discoveries and based on these new maps. What effects this has on these bubbles and how it changes the actual composition of stars and planets formed in there, that's one question nobody can answer just yet. And partially because it's been actually extremely difficult to find these magnetic fields and to study them in more detail. And so even though ESA's Gaia telescope can generally pinpoint the exact location of various stars or various really bright objects, it's not able to see the magnetic fields or anything in radio frequencies. And so instead the scientists had to rely on some of the older data from the Planck spacecraft that became really famous for creating the most accurate map of the cosmic microwave background. So it was actually able to see microwaves, which means that it was really good at looking at microwave frequencies. Frequencies that are somewhat relevant when looking for magnetic fields as well, with the data from the telescope being able to see some of the polarized light produced by various magnetically aligned dust particles present on the outer surface of this particular bubble. And in this case, the magnetic alignment of the dust particles allowed the scientists to then see the orientation of the magnetic field visible right here. And so when looking at some of the data from the Planck telescope, they were able to see all of this dust on the surface of the bubble, with a lot of the dust pointing in different directions because of the magnetic lines, which confirms an older assumption that as the bubble expands, the magnetic field seems to be swept up on the surface of the bubble and expands along with it. Which by itself is also a really important discovery, because it definitely confirms the influence of magnetic fields in galactic evolution and in star formation. And today, when using various computer simulations or supercomputer simulations in predicting the evolution of molecular clouds and star formation, most of these simulations generally ignore the effects of the magnetic fields. And not because the scientists don't want to include them, but actually because it's extremely difficult to implement them, because our general knowledge and understanding of these phenomena is, at the moment, extremely limited. We still have no idea what effects this all has on the galaxy and the production of various stars in various clouds. And so hopefully this new discovery will serve as the foundation for some of the new studies, specifically focusing on the effects of magnetic fields on star formation in various superbubbles. We probably still are not going to be able to model it just yet, but at least now we can sort of observe it, discovering what effects the surface of this bubble has on several different molecular clouds that exist around it and are visible right here. And so by trying to combine these observations with the observations of various types of star growth, we might be able to finally figure out how these magnetic fields influence the evolution of various stars, which is of course not something new and not something that we didn't know before. For example, several studies have already discovered that various types of wind shock, and of course the effects from the jet itself, dramatically change the formation of stars in just a few thousand years. And in certain systems, some of the stars get these tremendously large jets, which dramatically change what the final star is going to look like. And all of this directly depends on the magnetic fields around the star and the cloud itself. This particular object, known as the HH object, is particularly mysterious, and you can learn more about it in the video in the description. And so hopefully in the next few years, as we get more data, and as our observations become more complex, some of the new studies can finally start combining gravity, magnetic fields, and a lot of other interactions in various galaxies, and resolve some of these issues, and find the explanation for a lot of these mysteries of star formation. But as of right now, the entire field is still in its infancy. These are exciting observations, but there are just very few explanations as to what's really happening here and what created all of these shapes, or what's going to happen to them in the next few millions of years. But we'll definitely talk more about some of these discoveries in future videos as well. Especially because I love finding these maps, because this is literally like Age of Exploration once again. Even though we sort of mapped planet Earth, we still have so much mapping to do in our galaxy as well. Hello wonderful person, this is Anton, and today we're going to be discussing this relatively new and somewhat intriguing paper that might have discovered something really unusual about the universe. Something that nobody expected. The universe, or at least the early universe, might have not really been symmetric, or in other words, it seemed to have some kind of a preference in terms of what we usually refer to as handedness, or I guess symmetry. Or to give you, I guess, a slightly better, more realistic explanation, if we were to create a bunch of stuff in the entire universe, we would assume that the equal amount of inverse or mirrored stuff would exist as well. So for every particle you would find an antiparticle, and for every particle-antiparticle pair, they would essentially resemble mirror images. Although in this case, this particular mirror image can refer to any property. Here's an example of a mirror image of charge, with the expectation being that we generally expect the universe to have both in equal amounts in order to basically make sense. But in particle physics, there are other types of symmetry, including something known as parity, which to some extent refers to handedness, or which way a typical particle would be spinning. And so overall, for many years, scientists expected all particles to basically be symmetric in every single way. But in physics there's also something known as CP violation, referring to certain unique violations of symmetry in certain types of particles. We've actually discussed this in one of the previous videos, but there was a discovery back in the 60s that eventually led to the Nobel Prize, with the actual story being a little bit more controversial, with the main point being that CP violation, or the violation of the symmetry, seems to exist in certain subatomic particles around the universe. But if you want to just read about this, you can also read the article about the so-called Wu experiment. This is a pretty intriguing story, and in essence shows us that something is actually going on in the universe after all. But in this case, this was very small scale, as in it showed us that certain particles seem to have violation of symmetry, but the vast majority out there seem to not. Most of the stuff seems to be symmetric. And by itself, this presents a small problem. The problem being that, how do we explain how everything actually exists? Or basically, why are we even here? If the majority of stuff out there is symmetric, and if all particles are actually equal to their mirror images, and they were produced the same way in the beginning of the universe, well, in that case, Big Bang should have produced equal amounts of everything in the universe, and that includes matter and antimatter, and it would only exist for a fraction of a second, annihilating and leaving energy behind. Or just to rephrase this, if the entire universe was actually symmetrical everywhere, technically everything should have been gone a long time ago, with all the particles annihilating in the process. If symmetrical, the universe should have produced an equal amount of matter and antimatter, and so something here just doesn't add up. Even though a lot of things in the modern universe seem to be symmetric, maybe this was not always the case. Maybe the early universe was asymmetric, thus explaining how matter was able to survive so long, and why there is more matter than antimatter, with everything eventually becoming symmetric over time. And that's of course something that has been confirmed. For example, we know that all electromagnetic forces seem to be symmetrical, and no asymmetry has ever been observed. But we also know that electromagnetism did not exist for the first few moments of the existence of the universe, with the electromagnetic force even connected to something known as the weak force, which we know contains asymmetrical features, which already hints at the potential asymmetry of early universe. But all of these so far are just hints and just theories. Is there any physical evidence? Do we have any evidence for any of this, or is it just as theoretical as dark matter? And it looks like the paper behind me points at this really strange evidence, something that currently has absolutely no explanation. So let's discuss this in a little bit more detail, talk a little bit more about how this was discovered, and what ramifications this might have. First of all, the title here is obviously a little bit long, but in a nutshell what the scientists did here was sort of intriguing and really interesting. They essentially realized that when it comes to mirror images, or basically parity, the most simple three-dimensional shape whose mirror images are going to be different is a tetrahedron. Or in other words, a tetrahedron is the simplest possible shape that cannot be rotated into its mirror image in 3 dimensions. The simplest 3D shape that has unique mirror images. And so the scientists behind this paper wanted to see if, well, hypothetically, can we actually discover a bunch of these tetrahedrons out there in the universe and see if the overall amount of them is going to be more or less equal, basically left-sided or left-handed and right-handed, or if there's going to be some kind of a preference. Is there going to be a larger number of, let's just say, certain tetrahedrons compared to other ones? Just for the sake of simplicity, let's call them left-handed and right-handed. And obviously modern theories and modern understanding of the universe suggest that they should be equal. No matter where we look, we should see equal amounts. And that's independent of what we look at. And so how do we even look for these tetrahedra out there? Obviously we're not going to be able to find specific shapes or specific stars of this shape. Well, what they did was kind of brilliant. They realized that you can actually connect this to various galaxies, specifically distances to galaxies compared to one another. In this case, this tetrahedron is formed by 4 separate galaxies, with the distance between each galaxies represented as R1, R2, and R3. And as you can see from the formula, R1 is the smallest distance, R3 is the largest. Or just to rephrase this, they looked at quadruplets of various galaxies out there. And the only thing that they had to know about these galaxies was the overall distance between them based on various redshift calculations. But to make calculations and observations much easier, they focused on galaxies known as LRG, luminous red galaxies, and specifically 280,000 such galaxies from the Baryon Oscillation Spectroscopic Survey and 800,000 other observations from a slightly different survey that was conducted by the same program. So basically they looked at over a million very bright galaxies whose properties were quite well known. And then they created these hypothetical 4-point correlation functions out of all of these galaxies. This actually created something like million trillion different possibilities, all based on 3-dimensional vectors formed by individual galaxies. Now once again, in theory, we should expect pretty much equal amounts of these left-handed and right-handed tetrahedra, no matter what kind of galaxies you look at, no matter where they're located, simply based on the idea of random distribution of matter across the universe. Now there might be some chunks slightly more concentrated than others, but as you average everything out, it should be more or less equal. But once they applied mathematical analysis to all of this, they discovered that in the first sample, the actual evidence for non-symmetry was really significant, specifically 3.1 sigma, which is already a huge discovery when it comes to new physics, with the second sample producing something even higher at 7.1 sigma. And none of this can be explained by modern theories of gravity, any kind of evolution of the universe, expansion of the universe, or even more hypothetical, less accepted theories. Or just to rephrase this, there is absolutely no explanation for why this was detected. No idea why there seems to be symmetry when it comes to galactic distribution. However, they do believe that this is maybe something that happened right after the Big Bang, potentially during the inflation period and before the fundamental forces became the way they are. And so as the universe suddenly expanded, for some reason, it seemed to have some kind of a preference for certain symmetry. And then, as the universe evolved over time, and as things like cosmic web provided the foundation for new galaxies, over time all of these new galaxies started to position themselves in what seems to be preferred type of a symmetry, creating a kind of a symmetric imbalance. Although the actual source of this symmetry is obviously unknown and will be currently impossible to determine. And because of this unusual, somewhat groundbreaking discovery, it's also important to talk about potential errors. And while in terms of errors, there might be some bias here, as in observational bias. So far this is all just based on the release from SDSS and just 1 million galaxies out there. We've actually discussed this previously, but the release from SDSS so far only covers this much of the universe. So basically it doesn't cover the entire universe around us, mostly because of the way that these telescopes work, where they usually look during nighttime, and how certain regions become somewhat unavailable. And so in theory, maybe it's just in these locations that things are slightly more sided. Maybe if you look here, for example, or over there, the actual sidedness will suddenly disappear. But at the moment this is really the only bias I can think of, and the only problem I found in this particular interpretation. There is, however, a solution to all of this in the future. Other galactic surveys, such as Dark Energy Spectroscopic Instrument, or ESA's Euclid telescope that's going to be launched sometime in 2023, are extremely likely to provide even more data to either prove this and find even more weirdness, or completely disprove this and discover where the mistake actually was. And so whether this was just bias that can be resolved by these telescopes, or whether this is actually something fundamental discovered here, we'll unfortunately only know in time. But until then, this is a pretty big discovery, and actually a somewhat unusual discovery that doesn't really have a very good explanation just yet. But the implication here is that if the universe was handed in the first few moments of its existence, it seems to be still visible today, and more importantly, it might finally explain why we're even here, why matter prevailed over antimatter, and why physical objects were formed over the last 13.8 billion years. But what other implications this has, I currently have no idea. It's actually a pretty big discovery, assuming that it's real, and so I'll definitely follow this up once there is more information, more data, more explanations, or once there is some other really cool explanation to why exactly galaxies seem to form this unusual handedness. Until then, thank you for watching, subscribe, check out all of the relevant links in the description below, where you can actually also find other unusual discoveries related to symmetry or unusual lack of symmetry in the universe that we've discussed in the last few years. Maybe support this channel on Patreon by joining channel membership or by buying the Wonderful Person t-shirt you can find in the description. And either way, stay wonderful, I'll see you tomorrow, and as always, bye bye.